بسم الله الرحمن الرحيم. أصحاب المعالي، أصحاب السعادة، الضيوف الكرام من الخبراء والباحثين الدوليين والمحليين، ممثلي الجهات الأكاديمية والبحثية، شركاء النجاح من القطاعين الحكومي والخاص، السيدات والسادة الحضور، السلام عليكم ورحمة الله وبركاته. وبعد، يسرنا في المركز الوطني لأبحاث وتطوير الزراعة المستدامة وبالتعاون مع وزارة البيئة والمياه والزراعة أن نرحب بكم في الورشة الافتراضية الدولية الثالثة التي تقام تحت رعاية معالي وزير البيئة والمياه والزراعة المهندس عبد الرحمن بن عبد المحسن الفضلي، والتي تأتي بعنوان تعزيز الحلول الزراعية الذكية والمبتكرة للنهوض بالقطاع الزراعي في المملكة العربية السعودية. تأتي هذه الورشة استمرارا لجهود المركز في نشر المعرفة ونقل المخرجات البحثية التطبيقية ودعم تبني التقنيات الزراعية الحديثة التي تسهم في رفع كفاءة الإنتاج وتحسين استخدام الموارد الطبيعية وتعزيز منظومة الأمن الغذائي في المملكة. تشهد هذه النسخة مشاركة نخبة من الخبراء والباحثين والمتخصصين في التقنيات الزراعية المتقدمة لاستعراض أحدث التجارب العلمية والتطبيقية وبحث الفرص التي من شأنها تطوير القطاع الزراعي وتمكين الممارسات الحديثة المبنية على البحث والابتكار. يسعدنا اليوم أن نلتقي بكم في هذا الحدث العلمي المتخصص الذي يعكس اهتمام المملكة بتطوير منظومة الزراعة المستدامة وتعزيز التعاون العلمي والمعرفي بما يدعم تحقيق مستقبل زراعي أكثر كفاءة واستدامة. نتطلع إلى يوم ثري بالنقاشات العلمية والتوصيات العملية التي تسهم في دعم تطوير قطاع زراعي أكثر ذكاء واستدامة في المملكة. نستهل أعمال هذه الورشة بكلمة ترحيبية يلقيها سعادة مدير عام المركز الوطني لأبحاث وتطوير الزراعة المستدامة الدكتور خالد بن مرشود أرحيلي.
دكتور سليمان الخطيب، أصحاب السعادة والمعالي، الضيوف الكرام من الخبراء والباحثين والمهتمين بالقطاع الزراعي، السلام عليكم ورحمة الله وبركاته. يطيب لي بداية نيابة عن المركز الوطني لأبحاث وتطوير الزراعة المستدامة وبالتعاون مع وزارة البيئة والمياه والزراعة أن أرحب بكم جميعا في الورشة الافتراضية الدولية الثالثة تحت الرعاية الكريمة لمعالي وزير البيئة والمياه والزراعة المهندس عبد الرحمن الفضلي، والتي تأتي تحت عنوان تعزيز الحلول الزراعية الذكية والمبتكرة للنهوض بالقطاع الزراعي في المملكة العربية السعودية. ندرك جميعا أننا نقف عند لحظة مفصلية تشهد فيها الزراعة العالمية تحولا غير مسبوق، خاصة ونحن نواجه التداخل بين ندرة المياه المائية وتغيرات المناخ والحاجة الملحة لتحقيق الأمن الغذائي العالمي. وتأتي هذه الورشة في وقت نشهد فيه تقاربا بين الابتكار التقني والتقدم العلمي. إن الحلول التي سنستكشفها خلال الساعات القادمة من الزراعة المحمية ونظم الزراعة العمودية إلى البنية التحتية الرقمية والإدارة الدقيقة للموارد تمثل تحولا جذريا في كيفية إنتاج الغذاء في القرن ال21. إن عقد هذه الورشة اليوم يمثل شراكة استراتيجية عالمية تجمع نخبة من الخبراء الدوليين لتبادل المعرفة والخبرات في مواجهة أحد أكبر تحديات عصرنا، تحقيق الأمن الغذائي المستدام في ظل التغيرات المناخية وشح الموارد المائية. ورشتنا اليوم تتناول محاور حيوية تمثل ركائز التحول الزراعي الذكي، حيث نستكشف النظم الزراعية المتكيفة مناخيا والزراعة المتحكم بها بيئيا والتي تعظم كفاءة استخدام الموارد، ونناقش الزراعة العمودية كنهج تقني واعد للمحاصيل الأساسية. كما نستعرض البنية التحتية الرقمية من روبوتات الحصاد إلى أنظمة الذكاء الاصطناعي وإنترنت الأشياء وتقنيات الري المتقدمة، وصولا إلى نماذج الأعمال الاقتصادية وشبكات البحث التعاونية التي تحول الابتكار إلى واقع تجاري مستدام. إن مشاركة هذه الكوكبة من الجامعات الرائدة ومراكز البحوث العالمية والشركات المتخصصة تعكس ثقة المجتمع الدولي في مسيرة التنمية الزراعية بالمملكة، وتؤكد التزامنا ببناء جسور المعرفة وتبادل أفضل الممارسات العالمية لتطوير حلول مبتكرة تناسب بيئتنا المحلية. في الختام أتوجه بالشكر الجزيل لمعالي وزير البيئة والمياه والزراعة على رعاية الكريمة، ولسعادة وكيل الوزارة للزراعة، ولجميع المتحدثين والخبراء المحليين والدوليين على مشاركتهم القيمة، ولفريق عمل مركز استدامة وفريق العمل من الإرشاد الزراعي من الوزارة على جهودهم المتميزة. نتطلع جميعا إلى يوم حافل بالمعرفة والحوار البناء، وإلى توصيات علمية تسهم في رسم خارطة طريق واضحة للنهوض بالقطاع الزراعي السعودي نحو مستقبل أكثر ذكاء واستدامة وازدهارا. والسلام عليكم ورحمة الله وبركاته.
السلام ورحمة الله. شكرا لكم دكتور خالد هذه الكلمة. ننتقل إلى الكلمة الافتتاحية والرئيسية للورشة، يتفضل فيها سعادة وكيل وزارة البيئة والمياه والزراعة للزراعة الدكتور سليمان بن علي الخطيب.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين، وأصلي وأسلم على نبينا محمد وعلى آله وصحبه أجمعين. المتحدثون الكرام، المشاركون الأعزاء، السيدات والسادة، أو مساء الخير جميعا أو صباح الخير أينما كنتم. في البداية يسعدنا أن نرحب بجميع المشاركين في النسخة الثالثة من هذا الحدث المهم حول ورشة عمل تعزيز الحلول التقنية الزراعية الذكية والمستدامة والمبتكرة للنهوض بالنظم الغذائية والزراعية بالمملكة العربية السعودية. كنا نظمنا سابقا ورشتي عمل دوليتين في وزارة البيئة والمياه والزراعة، عنت بالزراعة العمودية بشكل أساسي والتقنيات المتقدمة في هذا الإطار. وقد لعبتا هاتين الورشتين دورا مهما في تعزيز تبادل المعرفة واستكشاف التقنيات المبتكرة لإيجاد نظم زراعية أكثر كفاءة، اعتمادا على أساليب إنتاج حديثة تناسب نظم الإنتاج الغذائي في المنطقة وخاصة في المملكة العربية السعودية. اليوم ننظم هذه الورشة في وقت يشهد فيه القطاع الزراعي تحديات متزايدة عبر تغير المحركات الاقتصادية المؤثرة في النظم الغذائية. في المقابل تبرز ابتكارات تكنولوجية تتيح آفاقا جديدة للمزارعين والمستثمرين والمجتمعات الريفية، وتعزز المساهمة في الأمن الغذائي الوطني. في هذا السياق أحرزت المملكة تقدما ملحوظا في السنوات الأخيرة. تجاوز إنتاجنا الغذائي المحلي من المنتجات الزراعية 16 مليون طن في عام 2024. المساهمة في الناتج المحلي الإجمالي تجاوز 31.5 مليار دولار أمريكي. وتمركز وتمحور إنجاز مثل هذه الأرقام على مجموعة من العوامل. سأتحدث عن عاملين من هذين العوامل. أولا، تطبيق الممارسات الزراعية الجيدة، تنويع المحاصيل، تطبيق برامج تحسين صحة وخصوبة التربة وصحة الحيوان، وأيضا الأصناف النباتية الواعدة وذات الإنتاجية العالية والمقاومة للظروف الجوية غير الملائمة. وفي تحقيق مثل هذا تم خفض استهلاك الموارد المائية غير المتجددة بنسبة تزيد عن 50% من خلال اعتماد أنظمة ري حديثة، سياسة تعزيز استخدام المستدام للمياه، وتسهيل استفادة المزارعين من الخدمات الرقمية والتكنولوجيا المتقدمة في إدارة مزارعهم. وتم تتويج هذا الأمر بإطلاق التحالف السعودي لتقنيات الأغذية الزراعية كأول تحالف من نوعه في المنطقة، يجمع قادة في مختلف أنحاء العالم في القطاع لتبني الابتكارات. وبالرغم من هذه الإنجازات، إن التطورات العالمية لا تزال تتسارع بوتيرة كبيرة، الأمر الذي يحتم علينا تعزيز قدراتنا على التعلم والتكيف والابتكار. نؤمن جميعا بأن ازدهار الأجيال القادمة يعتمد على بناء نظم غذائية قوية ومرنة ومسؤولة بيئيا، وأن تحقيق هذه الرؤية يتطلب تقنيات وحلولا عملية وعلمية منخفضة التكلفة، عالية الكفاءة، ومتاحة للجميع، وسهلة الاستخدام. أخيرا أؤكد، وكما بات معروفا ومعترفا به على نطاق واسع عبر العالم، أن تبني التقنيات الزراعية الحديثة أصبح ضرورة استراتيجية لا خيارا تقنيا. وذلك بالاستفادة من مجموعة واسعة من الأدوات الرقمية والتحليلية كالاستشعار عن بعد، الذكاء الاصطناعي، الطائرات المسيرة، الروبوتات، وتطبيقات إنترنت الأشياء، ونماذج التنبؤ بالإنتاجية، وأنظمة الإنذار المبكر، ومنصات تحليل المخاطر المتكاملة، مما يتيح فرصا جديدة لتحسين الإنتاج، تعزيز القدرة على الصمود، وتحقيق إدارة أكثر كفاءة للموارد الطبيعية. وفي الختام أود أن أشكر العاملين في المركز الوطني للاستدامة على جهودهم التي بذلوها لتنظيم هذا الحدث، كما أشكر جميع المتحدثين وأعضاء حلقات النقاش والمشاركين الذين انضموا إلينا من مختلف مناطق العالم في هذه الورشة، متطلعا أن تكون هذه الورشة تقدم رؤى وخبرات تسهم في تعزيز مسارات الابتكار، استدامة النظم الغذائية والزراعية، وأرجو أن تثمر هذه النسخة الثالثة النتائج قيمة تدعم جهودنا في تطوير النظم الغذائية المستقبلية. السلام عليكم ورحمة الله وبركاته.
وعليكم السلام ورحمة الله. نشكر لسعادتكم هذه الكلمة. الآن ننتقل إلى الجلسات، نستهل الجلسات، وأود الإشارة إلى أنه سيكون هناك ترجمة للغة العربية، الجلسات تكون باللغة الإنجليزية وسيتم ترجمتها فورية للغة العربية. Henry, now the mic with you.
Assalamu alaikum and hello. Thank you so much for being here. My name is Henry Gordon Smith, and I have the privilege of being the moderator for today's event. I'm the founder and CEO of Agritecture, and it's so exciting to have all of you joining from around the world for this third international virtual workshop. And thank you to Estidama and Miwa for hosting this today. Now we have 11 exciting speakers from around the world, and I don't want to have you wait too long for us to begin. We're going to have speakers across 4 different sessions, and then we'll have a Q&A session that I will lead with the speakers for that. And our first speaker today is Professor Hail Rehan, who's going to be speaking to us about controlled environment agriculture, building scalable models for resilient and efficient farming systems. Before Professor Hail begins, I want to tell you a little bit about him. He's a global leader in agricultural technology, plant biotechnology, and is renowned for his pioneering advances in controlled environment agriculture. This includes greenhouses and vertical farms. He's an associate professor for agricultural technology at the University of Plymouth, and his award-winning research spans global food systems, sustainable food systems, AI-driven crop optimization, and much, much more. Dr. Hail, are you there? Wonderful. We'll take you off mute, and we're ready to go for your presentation. We're looking forward to it. Thank you for being here.
Thank you very much, Henry. It's much appreciated. I will just try to share my screen. If you bear me a sec. Can you all see my screen? Cool. First of all, thank you very much for the invitation. It's a great pleasure to be with you today, and I very much looking forward to listen to the other speaker as well. So my talk, basically, I will be talking about completely controlled environment agriculture, building scalable model for resilient and efficient farming system. I guess most of us are aware of the great advantages of using vertical farming, and I would prefer usually to call it completely controlled environment agriculture system rather than vertical farming, where we control all aspects of a growing condition. There are a great deal of advantages of using such a system, such as this system can be built anywhere, basically, and also it provides year-round production system. The production is pesticide, herbicide free. There is no need for transportation because this system can be built close to the consumption point. The product has much longer shelf life because the bacterial load on plants are significantly less compared with the greenhouses and open field. And most importantly, we can control the quality, we can control the yield through controlling the growing environmental condition. However, this comes at a high cost. And the cost is the cost of the energy, basically. The cost of energy is relatively high because we don't depend on sunshine to power and energize the plant. Basically, we depend on LED lighting system. And if we look at the breakdown of the production cost using vertical farming or completely controlled environment agriculture system, we notice that there is around 27% goes to the electrical cost. And I don't know why the slide is skipping itself.
Yeah, Dr. Heil, if you just want to try again to share the screen. Sorry, a bit of a technical challenge. Appreciate your patience here. But just try to share your screen again and we'll get that set up.
Oh, sorry about that. I don't know what happened. So
it's okay. It's the nature of these digital conferences. It's a great way that we can all access it, but sometimes there's a little bit of flexibility necessary.
Is my screen clear now?
Let's try and get it to full screen and we'll see if our technical colleagues can pull it up into the main one. Just go to the full screen mode, yeah.
Yeah. Is that all right now?
That looks like the speaker mode. If you go back, just click on the regular presentation mode.
Can you see my slides now? I'm sharing my screen.
Is that good, Mustafa? Okay. Thank you.
Do you see my screen now?
Yeah, I think it's in speaker mode. I apologize, everyone. But if you just exit this mode and go back, this is a particular type of presentation mode, and then we'll click present again. So you see at the bottom there, next to the magnifying glass, there's a sort of yeah, just a little bit over.
In the case of Saudi Arabia, the percentage would be much higher. It would be more than 27% because the labor cost in the Middle East is significantly lower than that in the West or in Japan. Two important points I would like to mention here. The first one, the power goes 40 to 60% for the lighting and 30 to 50% to the HVAC system. And the HVAC system in the case of Saudi Arabia would be a bit higher as well because the temperature in the summer is quite high. So in our work, we focus on the lighting and on the system, and we aim to reduce the power consumption. So it's all about energy cost really. And whenever we can and wherever we can reduce the energy cost, this a significant value to the system. So we've got a few projects. I will be talking about a specific one, and the project I will give an overview about is Advancing Control Environment Agriculture with Dynamic LED Lighting System and Artificial Intelligence. This project is funded by Biological and Biotechnological Research Council in the UK, and it's for around $2 million, and it will last for 3 years. So we are in the middle of this project. So when we talk about lighting technology for control environment agriculture, there are significant number of companies out there producing really very various type of lighting for control environment agriculture. However, if we look about the efficacy and efficiency of LED lighting system, we will notice that the red color, has the highest efficiency and efficacy. And maybe this is why most of the lighting company included significant amount of red in their lighting spectrum. Now, this might save a bit of energy, but it's not necessarily the right spectrum that feed the plants. So at the University of Plymouth, we wanted to dig a bit deeper. So what we did, we got 15 plant species. We extracted the pigment of those plant species and we ran them through spectrophotometer to see what is the absorbance profile of those plants. And we noticed that there was two peaks, one peak about 663 and one peak in the blue region. One of the interesting aspects, we noticed actually that the peak of absorbance was at 435, and most of the LED lighting system produced commercially, they produce the blue at around 450 nanometers. So there is significant difference between, in terms of the absorbance between 435 and 450. And we thought, that's quite interesting. So we got a basil as a model plant and we run the pigment through spectrophotometer again. And we noticed actually there's a three peak, one for the red at 663, one for the blue, and one for the UV. I will ignore the UV for now. We are doing significant amount of work in this area. However, I will focus on the red and the blue. Again, with the basil, we noticed that the absorbance, the maximum absorbance was at 435 rather than 450. And we thought actually we need to do some more work here. So we did the quick experiment with basil and we applied for lighter treatment, one greenhouse condition, one we applied 1:1 red to blue. And the other two treatments, we applied the ratio between red and blue we observed in our profile. However, we used blue at 435 in one of them and blue at 450 in the other treatment. And we were very pleased. And this is our treatment compared with what's used commercially. This is our treatment here, and this is what's used commercially. We were very excited and very pleased with the result we obtained. We noticed significant increase in the physiological aspect of a plant at various developmental stages when we used the blue at 435 compared with the blue at 450. We noticed significant increase in the yield parameters, for example, number of leaves, height, fresh weight, dry weight, leaf area. So 435, blue at 435, really promote the growth, yield, and even the content of essential oil in basil plant. We were really excited about it. We did publish this paper. It's available for free online and everyone can have a look at it. And we did similar work on various plant species. We worked with lemon balm, we worked with basil, with lettuce, and various other plant species. However, when we did this work, we noticed that there are few challenges, when it goes to testing the optimal lighting system for control environment agriculture. And when we talk about light, we need to consider, four main aspects. We need to talk about the intensity, take it into consideration spectrum, the energy consumption, and the control and sensing technology. Now, when you have light and you apply light treatment to produce different colors, the first challenge you face is that once you start applying different light treatment, the intensity goes significantly down. So I'm aware that there are some research light out there where the lighting is the panel has 9 colors, but if you look at those panels, you will find 70 to 80% goes in specific colors, and after that, small portion of other colors. From research point of view, this is challenging because this limits your ability to maintain your intensity and apply various light spectrum at the same time. So what we did, we start working on this and we designed our own lighting system. We designed this panel. Now this panel is overspec'd. It contains 9 colors. And it can produce up to 4,500 micromole light intensity. It's a 3.5 kilowatt lighting panel. We will never use it at that capacity, to be honest with you, but having this panel in this specification enable us to apply any light treatment without impacting and affecting the light intensity. So assuming we are working with wheat plant or cannabis, we can easily produce 600, 700 micromole light intensity with any spectrum we would like to have without impacting the light intensity. So we did this. However, whenever we apply high light intensity, the light, although LED produce low heat, when you apply high light intensity and when you have 1,000 or 100 of those lighting panels in commercial lighting system, it will produce significant amount of heat. And when you produce significant amount of heat, you need to cool down, and this will increase the cost of your HVAC system. So what we did, we designed water-based cooling system that goes in the back of the panel. And this is just a couple of centimeters thick, and it's connected to external chiller. And that means we cool the light using water. We significantly reduce the need of cooling using HVAC system. And moreover, we can make use of this heat produced by this lighting system somewhere else, for example, to warm close by greenhouses or to warm offices in the winter months. So this will significantly reduce the energy consumption in vertical farming setting. Now, we've got the capacity of the lighting system. We reduce the need of cooling down because we are using water-based cooling system. We would like to optimize the light spectrum suitable for various plant species in order to control the growth and yield. This is really challenging. This is very much time consuming. We publish significant number of papers in this area, and we know how much time it takes every time to take the spectrophotometer, go test the light spectra, come back to your control system and, to do this process. So what we are working on at the moment, we are working on designing this spectrophotometer. So rather than doing things manually, we will have net of this spectrophotometer distributed across the light, the plant canopy, and this is connected to the lighting system here. And basically, this also gives us an indication about the absorbance, the reflection, and the transmitted light through the canopy. And it's connected to the lighting system itself, so we can automate the whole process. Moreover, what we do, we apply various types of light spectrum, and we take sample for chemical analysis. And we are trying to develop AI technology, artificial intelligence technology, in order to control the growth, the quality, and the chemical profile of various plant species through controlling the light spectrum. My colleague, I'm leading this project, as I said, is funded by BBSRC, and it's a joint project between the University of Plymouth, University of Highland, and Phytom Life Sciences. And I got my colleague, he produced a little video to demonstrate, just to give you a clearer idea about what we are doing. It's just 1 minute video. We'll share it, and after that, I will crack on with the presentation. So basically, this is a powerful research tool that would save significant amount of time, and it will empower us to produce significant amount of data that could be connected to artificial intelligence to maximize the output of our research. I would like, at the end of the talk, I would like to thank my team. We've got Professor McFuller, Associate Professor David Jensen, we've got Dr. Nofal Jafar, Toby, Miguel, Liz, and Lauren, and we all focus on various aspects of this project, from developing the spectrophotometer to test it with various plant species, to connect it to artificial intelligence software to maximize the output of it. So far, we reach really interesting stage. Our lighting system is ready, the spectrophotometer is ready, and we are testing the prototype of this technology in 2 plant species, on basil and on cannabis as well. We are aiming to patent some of the output early next year as well. And we would love to collaborate with as many as possible from you guys. We would love to talk to whoever is interested in this technology. I would like also to quickly mention about the other part of work that we do at the University of Plymouth, and it's the agri-pharmacy, because we use control environment agriculture in order to produce pharmaceutical plant species, and after that we test this the plant extract on for various aspects of pharmaceutical application, starting from anti-cancer, antibacterial, antimicrobial, and human physiology. And we've got the team here, Lynn, Simon, and we've got Lucille, we've got Phil, and the rest of the team who focus on various aspects of medicinal plant species and its impact for pharmaceutical industry. So we try to complete the circle, starting from technology, plant production, chemistry, to pharmaceutical application. This is in brief what we are trying to achieve at the University of Plymouth, and I would be happy to answer any question. Thank you. You are on mute, Henry.
Yeah, thank you so much, Dr. Heil. I really appreciate that presentation on CA. You can stop sharing your screen now. Thank you so much for joining us on that and sharing controlled environment agriculture, which is obviously one of the many ways that we can integrate agriculture into Saudi Arabia in an important role. So thank you for sharing that. We're going to continue on this discussion for these farming systems for climate smart agriculture, but we're going to shift to a different topic, more about climate smart, diversified farming systems. This is going to come from a colleague of mine, a friend of mine, Christine Gold, who's the founder and CEO of Giga Futures, based in Switzerland and working around the world. Christine, when you have your audio on, please just say hello, and I'll introduce you. Christine, as I mentioned, is the CEO of Giga Futures. This is a strategic innovation and investment platform that partners with global corporations, investors, and startups around the world to unlock the massive billion-dollar opportunities, really massive opportunities across food, agriculture, and climate. Christine has vast experience from the startup world to working with investors and corporates. She is a really superstar in this subject, and we're excited to have her here today. Christine, can you hear me? Okay, we'll hang one moment. She's getting her slides there in place.
Hi, everyone. Greetings. Yes, I can hear you. I guess the question is, can you hear me?
Yes, loud and clear. So thank you so much.
Yeah.
And sorry for the delay, but please proceed with your presentation.
Okay, perfect. Wonderful to be here. I'm calling in from a very cold Switzerland. And I have a little bit of a different presentation than some of the others, as it's not so much of a technical presentation, but more of an overview of the opportunity and how to approach climate smart agriculture in a country like Saudi Arabia and a region like the Middle East. To set the scene, first I'll quickly introduce myself. I have spent more than 2 decades actually working on the front lines of agri-food innovation. I've worked at multinational corporations for large and well-known scale-up companies that have been fast-growing in the space. And I've built the world's first and leading global accelerator program for early stage innovation targeting the next generation. I'm now advising big multinationals, startups, and I also work with governments around the world. And one of the things that I've come to know and believe is that really Saudi Arabia represents a convergence that I've rarely seen, which is the convergence of need and opportunity that is aligned with policy and capital. And this is a really exciting moment to now be thinking through how to take this and to turn it into real action that can transform food systems and help to nourish people and build resiliency against some of the climate challenges we face. So why Kingdom of Saudi Arabia? Why now? As mentioned, there is this convergence of need and opportunity. There's kind of a perfect storm that's creating urgency. And this urgency can lead to a truly genuine leapfrog opportunity for agricultural transformation. I think we know the stats, but just to give them at a high level, we do have, dependency on food imports that is creating an economic vulnerability. We have depleted aquifers, we have temperatures intensifying, and we have farmers struggling, right? And we know that our traditional methods are failing. We're seeing widening yield gaps and declining soil health. But within this, we have big opportunities. The Middle East region at large has a large youth population. Saudi Arabia is at over 70% under the age of 35. And we know from our world's young people that they are entrepreneurially minded, digitally savvy, and ready to bring new types of solutions to bear that can really make a dent on these prevailing challenges. There's also over $9 billion in committed capital, which I hope we'll even see more to come going forward. And as mentioned, this kind of policy vision articulated in the Vision 2030. And what Saudi and the Middle East also has are some leading research institutions, including KAUST, which I've spent a lot of work with some of the researchers and startups coming out of that ecosystem. And I think that can really leverage some locally relevant solutions. So this, brings really profound opportunities for the country and the region. And some of those opportunities mean that we can address food security and climate goals in a very tangible way. Localizing production, improving productivity, making sure that we can achieve water gains as well as nutrition gains. And there is a correlation when we are, for example, improving soil health and improving water use efficiency, that we are also improving nutrient density in crops that are grown in these systems. We can cut GHG emissions and play a key role in mitigating climate change and adapting to climate challenges. And we can build that regional leadership that can also lead to global leadership. And really the vision is that how can Saudi become a global hub for climate smart agriculture, all the while generating.
One second. Yes. So sorry to interrupt. I apologize.
Yes.
Nothing wrong with your presentation. I just want to remind all the attendees here that there is a translation option, right? So many, our talks are in English here today. And if you go to the More button with the 3 dots at the bottom, you can click on interpretation and you can choose Arabic, and that will bring you to a room where we have a live translation of the excellent speakers today. I apologize sincerely, Christine, for interrupting you. You can continue now.
No, amazing. I'm glad to know that. And if I need to talk more slowly, do let me know that too. Although there's a lot going on with the pings I'm seeing, so just feel free to interrupt me along the way. But I think here we have the chance to of course, money speaks. We want to generate that economic value. But as mentioned, this is the opportunity of a lifetime for Saudi to step in and really become this global hub for innovation. And from what I've seen too, in terms of the innovation that's being deployed from some of those research institutes like KAUST, this is very real and very tangible. Now I'm going to go quickly to the next slide. Sorry, oh my gosh, so many pop-ups here. Okay. Sorry about that. So how do we do this? I think that there's a really important message here around strategic diversification. And strategic diversification means that we're not going to choose one crop, one technology, one solution to go all in on, but actually really look at the wide breadth of opportunities we have. And I want to present 3 kind of dimensions that I think we should focus on. One is around diversifying the genetics, and that means for crops and livestock, and really honing in on local and indigenous crops as a priority space for innovation and investment. Also looking at diversifying production systems. So today we're going to be hearing a lot of presentations going from, controlled environment agriculture, how that can be used with data centers, looking at different types of technologies that can be integrated into those systems. But I think we can look beyond CEA into some of these, smart, digitally empowered irrigation systems, smart agriculture for the farm, and even regenerative ag and silvopastoral systems. And looking at how we can diversify the resource flows. We felt hard in Saudi and the Middle East, the constraints that happened after the pandemic and from geopolitical tensions and wars that constrained access to fertilizers and to foods. And so these are things, it's how do we create a local bioeconomy and circular economy where every waste stream becomes an input into these diversified production systems. So let's double click into these different dimensions. Dimension one, diversified genetic portfolios. One of the key messages I want to say here is like, let's lean into these local and indigenous crop opportunities instead of relying on replicating crop models and scenarios from other markets. So looking at heritage grains, for example, that have been traditionally grown in regions like the Middle East, and looking at your local wheat varieties. And I think this is something you all know well, being there, that has created some vulnerability relying on imports of wheat. Looking at biosaline crops, Salicornia, we've heard a lot about that. I was just in UAE, and there obviously is the Institute for Biosaline Agriculture, but looking again at how those types of crops can be leveraged. I don't know who's drawing on the slides, but I just want to make sure that's okay, because it's not me. But I think that
I'm investigating that. There's a lot going on, Christine. Just keep going. You're doing
okay. Okay, yeah. And I wanted to call out Sesame too, just because I've seen an interesting startup or research program from KAUST on this around breeding programs, and looking to in aquaponic systems at not just going into tilapia and some of the fish that are kind of used en masse globally, but what are some of the Red Sea varieties, right, that could be brought again and more mainstreamed. And I'll talk a little bit about how that type of focus actually fits into generalized market trends. Dimension two is diversifying production systems. And so again, looking beyond kind of what I think is a large focus in the region, which is controlled environment systems, and understandably so, but looking into, precision irrigation and digital ag and some of the regenerative dry land systems, and really studying what's happening across the region from traditional practices, but also globally, and seeing what makes sense, how that can be applied into the unique conditions of KSA and the Middle East. And finally, around diversifying resource flows, I'm sorry for all the markups on the slides. I'm not sure where these are coming from, but again, looking at how all waste streams can be repurposed into bio inputs. So from aquaponics, obviously, when you have the fish waste, that becomes a nutrient input that can be used in controlled environment agriculture, but also in field agriculture and regenerative agriculture programs, and the water can be reused. Livestock, same thing. You use the manure as an energy source and pelletize it. You can use it as a fertilizer, desalinization. I mean, again, just integrating everything so we have a zero waste paradigm, and you actually have access to more inputs that are cheaper and more readily available and are less reliant on imports. And obviously there's a huge biomass valorization opportunity. So the big message from this slide is same resources, multiple revenue streams, closed loop, zero waste. And as I alluded to, doing this doesn't just make sense to solve the challenges, it actually aligns with market demands. And so looking at like what consumers want in the country and region, there is an increased demand for local and organic foods. And with the high youth population, there's an openness to reconnecting with traditional foods and reconnecting with heritage crops. So this is a big opportunity for agriculture to kind of tell the stories. This is an innovation opportunity, it's an investment opportunity, but it's a consumer marketing story too. There's also, a real need for more traceable and transparent supply chains. This is being mandated by regulations. It's required by halal certifications. And again, consumers are very interested in knowing more about where their food comes from, how it was produced. And as more corporates are also committing to scope 3 emissions reductions and making ESG commitments, those are, spaces that can be leaned into from a marketing standpoint. Pesticide-free production aligns with the demand for more organic foods, and secondary standards that are being established by retailers, for example, are extremely important. You have the baseline regulations, of course, but retailers are even putting in place more stringent regulations for maximum residue levels or zero residue levels. And again, this is a great white space opportunity for bio inputs to step in and help to address that. And then, of course, is the whole aspect of supporting your local farmers and smallholder farmers in particular. So how can innovation become part of the local farmer story? How can they be given access to new types of bioinputs, new types of digital tools and technologies? We call it sometimes in the startup space appropriate tech. So that's affordable and right-sized to the needs and realities of their farming operations. And I think what we have seen so often, for example, in automation and machinery, is like the big machinery companies develop solutions for the row crops in the Americas, but actually we need to take the same concept but develop them for, you know, the types of crops and the conditions that are real to the Middle East. So same principle, automation and everything it can offer, but like, again, being developed with a new type of farmer in mind. So I think my big message on what to do with this information is the time is now, and there's a real opportunity again to tap into these market trends and innovation opportunities. But what we don't want to do is just do more talk and no action. So my message is maybe it's not about more accelerators. It's about taking solutions that work, and there are many coming from the leading research institutes in the country and region, and get those into the hands of farmers and start to build those scaling pathways. So I think that there's kind of three critical areas to focus on. One is on de-risking the technology and creating living labs, for example, where you can identify beachhead farming operations that could test and deploy these and bring, again, real insight from use cases back into the innovation cycle, so those can be brought forward more quickly and efficiently. I think we need to build farmer networks, again, where farmers can share with each other their experiences using some of these new tools and innovations, and create a new type of extension that is less focused on importing solutions from other markets, and using what's happening in Saudi to create a new type of extension that's locally relevant. And we also need to inject patient capital for agriculture. So it's great to see the investment commitment, which is significant, and congratulations on that. But we need to match that with patient capital that really understands the realistic timelines of agriculture. But VC is set up for 7 to 10 year returns. That doesn't happen in agriculture. There are real risks and realities that have to do with biological timelines and farmer risk profiles. So it's important to keep that in mind and find the right type of investors that can put the capital in that allows those returns to happen in the right way. So the opportunity is now. Now is the time to tap into this young and dynamic population, world-class research, the capital commitment that's already there, that can be matched with further patient capital, the policy alignment, and the regional leadership position, and make it happen with execution. So my call to action is let's start to identify the technology gaps and accelerate real on-farm pilots through living labs. Let's strengthen ecosystem partnerships. And again, I think that there's an opportunity for local impact through global collaboration and regional collaboration. So again, mapping best practices from other regions, seeing what works and what doesn't, and applying it to the specific needs and realities and opportunities of KSA in the region. Mobilizing investment and empowering your local farmers really with local solutions. Given all of the challenges, there's no time to play small. Now's the time to go giga. So let's do something big. Happy to take your questions, but I hope this helped to set the scene about the time, the need, and the urgency. Thank you very much.
Thank you so much, Christine. I think I can speak for everyone when I say thank you for that presentation on really specific things that Saudi Arabia can do. And it's great you mentioned these living labs. Estidama itself, I remember when I first visited, has 3 different types of greenhouses, varying technologies that farmers can visit and see how those play out. KAUST, of course, has a lot of applied research and action. So really good recommendations and encouragement there. And we'll bring you back in a moment for the Q&A period. So thank you so much. But as we continue on this session 1, Farming Systems for Climate Responsiveness and Efficient Production, it's my pleasure to invite Dr. Joke Kampen from Wageningen University of Research in the Netherlands, considered the top global university for agriculture. And Joke is going to speak to us about zero-waste farming models to maximize resource efficiency and reduce emissions. Joke, if you want to try pulling up your screen here. I have a short bio for you, but let's try and get you to screen share. And how are you doing?
I'm doing well, thank you.
Okay, welcome. We're so glad you're here and excited to hear from you. And everyone, we're going to have Q&A from me with the speakers at the end of the session after Joke, so stay tuned for that. Go ahead.
Okay, you can see my screen?
Yes.
Ah, perfect. Okay, welcome. Well, I had to present quite an ambitious subject, zero waste. That's quite ambitious. Well, first I'd like to thank the organizing committee for inviting me and to give this talk, this challenging talk. I will briefly introduce myself. Jouke Kamp, I've been working already for more than 25 years in Wageningen. Also did my PhD here. And currently, or in the last 15 years or so, I've been working as an international project manager within Wageningen. And in that role, I also visited numerous times the Middle East, Saudi Arabia, Emirates, Qatar. And well, in that capacity, we also set up, or we were joined to set up the research center Esidama, from which a lot of results I'm going to present are in this presentation. And I also work as a program manager on energy transition, and that also has to do, of course, with zero waste. So there's a big program here in the Netherlands where we try to refrain from using too much energy. So also that is part of the talk I'm going to present here. But it's an ambition challenge to have zero waste farming in the end. Because if you look at farming, there are numerous streams which go into production, basically. So there's energy, of course, also in Saudi Arabia and in the Middle East, quite some energy is being used, not only for running the system, like the PET system, but also if you look at the water source, which is often using RO, it also consumes a tremendous amount of energy. So also there, in that respect, you also need to look into how that can be reduced. And of course, there are also other inputs, like the chemical inputs, of course, the inputs of nutrients, which is also quite intensive in terms of mining. So also there, if you want to go to zero waste, you need to do a lot of effort. Water, of course, as I indicated already, a lot of water comes from the sea, but also from wells, which are quite deep. So also there, a lot of energy is used, but also in the end, the water, of course, also is a flow which you also want to control. So all those aspects, and well, they are nicely aligned in this nice graph. You have to consider if you go to zero waste agriculture. Well, if you look at the greenhouses in the Middle East, well, here you see some pictures. They are predominantly operating with the PET system, which works quite well. There are some challenges. So, for example, as water becomes more saline, you see a lot of salt accumulation sometimes on these PET walls, and also, well, that damages the infrastructure. So there's also a tendency to reduce the water consumption because, it's quite difficult to operate with when the quality of the water is not so well. And also inside, well, the majority of the growers are still growing in the soil, as you can see from these pictures. So also there should be a tendency to go more to soilless, which of course also applies to the goal of zero waste farming. Well, as indicated, protected horticulture is really a good way to reduce your inputs. As you can see from these graphs here, those are for the Netherlands, but if you grow capsicum, for example, outside in the Netherlands, you can only grow 3 kilos per square meter per cubic meter of water, roughly. Here in the Netherlands, if you go put it into a modern greenhouse, you can reach 43 kilos per cubic meter or per square meter of greenhouse. So there's a substantial increase of production if you go into protected horticulture, and for that reason, it's good to see what if this also applies to other countries. And for that reason, and basically because this technology was all applied, of course, in the Netherlands, and 10 years ago it was said that we should also apply those technologies in the kingdom, and then Esidama was established. So which is quite good because all these water saving, energy saving technologies can then be researched under local conditions. So here you see a nice picture of the research center in Riyadh, and it basically has 3 levels of technology. So you have the low tech, which is basically the standard technology, so what they are currently using. So that's normally this tunnel type of greenhouse. Then the mid-tech, a slightly more advanced greenhouse, a glass greenhouse in this case, and then the high-tech, which is the most advanced greenhouse, having air conditioning system. So basically a closed greenhouse. And these were all compared in terms of mainly water use in Estidama. And here you see some results. So basically, over all the years, all the trials, we always measured the amount of water going into irrigation, going into the evaporative cooling system, so the pad wall basically, and going into, in the mid-tech case, going into the drain, and in the high-tech, going into the condensation as well, because as crop transpires, all the water which is transpired is condensating in the coolers, and it can also be recaptured again and reused again. So what you see here is that you really can have a big transition if you go from the low-tech or the standard tech towards the mid-tech. You already see a water saving of 35% only on the evaporative cooling. So just by alternating the design, so making the fans slightly higher, really gives a tremendous saving on water. But also if you look at the water use efficiency, because in the mid-tech greenhouse you can also have a much higher production with less water, as you see from the graph above, where in the mid-tech you only use 3.5 cubic meters on an annual base per square meter, whereas in the standard technology it's 5 cubic meters. Combined with the higher productivity, you can increase your water use efficiency just by changing the system. You can double the water use efficiency. You can also, of course, go into the high-tech system. That's saving a lot of water, because then you only use 200 liters per square meter on an annual base. This is just a graph to simplify the numbers I just showed. So assuming you are producing in a petafan greenhouse, in order to produce 1 kilo of tomato, you need roughly 50 liters of water and half a kilowatt hour of energy. If you produce it in a closed greenhouse, you only need 4 liters of water to produce 1 kilo of tomato, but your energy demand increases largely, because then you need 6 kilowatt hours. So there are two ways to produce, either in the petafan or the closed. And in the one system you use more water, and in the other system you use more energy. And if you then put all this data into numbers by which investors or growers can determine what system they should apply. With Estidama, we made this overview where you see all the costs related to the production, but also the investment cost and how much you are producing. And then in the most lower line, you see the operational cost per kilo of tomato. And then you see, in the standard technology, you need around 1.6 reals per kilo. In the more advanced, you only need 1 real per kilo. And in the most advanced greenhouse, or the closed greenhouse, you need 2.5 reals per kilo. So, based on investment cost, or if you're an investor, then it's best to go for this slightly more advanced system, because that has the lowest operational cost, and thereby, of course, the initial investment costs are higher, but given the fact that the operational costs are much lower, in the end, you will get a better return on investment. Another thing, if you look at zero waste, it's also good to look at the substrate material if you're growing for soilless cultivation. So we looked at Estidama at different substrates. So volcanic rock, which is available in Saudi Arabia, perlite, which you can also locally find, and date palm waste, which, Saudi Arabia has a lot of date palms, so a lot of waste, but you can utilize that waste as a substrate. So we also did some research on that, and to see if that substrate is comparable to rock wool. And as you can see from this graph, we are, the date palm waste, but also the volcanic rock and the perlite gave more or less the same production as with the rock wool. So it's a good alternative, and it's locally grown, so it's locally harvested, so zero waste in that case as well. Another thing which was also addressed already in the previous talk is to look into local predators, because I think if you want to go to zero waste, you should also reduce your chemical use for the pesticides. And well, we already saw at Estidama trials that if you integrate the pest management into your operation, you can really reduce the pesticide use. And one thing we have to consider is that we have to find local predators to address these local pests. And I think there's still a lot of research can be done in that field. But it's possible. We showed at Estidama that it's possible to grow without any pesticides in a good crop. Then something on which was also addressed by Christine. I think in the end you have to go for feasible solutions. So solutions which especially for small farmers can handle easily. So for example, on the top right picture, you see a very simple irrigation system where the actual application of nutrients is not done by electronics, but just by mechanical supply. So when there's a water flow, automatically concentration of nutrients is being added to the water, and this makes it very robust and very easy to operate. And I think that's one of the things we should look for the smaller farmers, that we get solutions which are sustainable but also very easy to implement. Also the Dutch bucket system you see on the left hand side in the picture, also that system is quite easy to adopt for farmers. And the fact that we saw from the research that placing the fence high reduced tremendously the amount of water consumption. Well, in a simple greenhouse, so in an existing greenhouse, we put up some iron air ducts on top of the fence just to have the same effect, so that the warm air is being sucked out of the greenhouse instead of this average air. And that also enhances the water saving tremendously. So these kinds of simple solutions, I think we should also look at that much more, because the majority of the farmers in Saudi Arabia are small farms, and they can utilize these simple systems in an easy way, and that's, I think, needed in order to become more sustainable.
Thank you, Dr. Joka. I know you have some limits on time, so I want to just move into the questions if it's okay with you.
Yeah, that's fine. Yeah.
I mean, so knowledgeable, so in depth. We can also bring up Christine and Dr. Heil as well, and we can start our Q&A session here. But I'm going to start with you, Dr. Joka, because I know you have some time limitations as well. And again, thank you for your presentation. I think when we look at what you're doing and all the extensive work with Estidama and greenhouses and bringing that research knowledge to the region, I think many groups in Saudi Arabia want to know, well, which is best, right? Like, what is the best greenhouse for Saudi Arabia, considering the humidity, considering the climate, considering the various other factors? And, your presentation gave us a small taste of that and the analysis comparing different types. But maybe I can put it this way. If you were to pick the sort of top 3 types of greenhouses that you would encourage, that you think based on your expertise make the most sense for Saudis to consider as they try to achieve Vision 2030 and the food security goals and get involved in this sector, which ones do you think they should focus on, should be looking most towards from a technological perspective?
Well, I think it depends slightly on the size, of course. So for the larger investors, I think the ones which are now being established by big companies like Al Dafa and Red Sea Farms, I think those type of greenhouses, which are more or less alike as the advanced greenhouses we have set up in Estidama, I think that's the best way. And I think it's also already proven from all these results from these big companies that type of greenhouse is best for the big investors. For the smaller farms, I think, at least they should try to make a multi-span greenhouse, so slightly larger than what they are used to, slightly taller as well, and place the fence more high, and try to adopt this soilless culture, because we saw from the research that it reduces pest diseases or diseases, and it also reduces tremendously the nutrient use and water use. So adopting those, and then with a simple fertigation system, as I've shown in the slide, I think that's already will really increase their production. I think they can easily double their production just by doing those changes to their system. Yeah.
Thank you so much. So some very specific and helpful and context relevant knowledge for greenhouses. That's really helpful. And of course, people can reach out to Dr. Joka to learn more. There's a lot of research he does, and he visits the region. If I could have Dr. Heil up here, I would like to ask you a question. If we can brought up, sometimes it takes a minute to get you up here. How are you doing?
Yeah, not so bad. Apologies about the sound not being displayed in the video. I was not notified, so I could hear it from my side, so I did not know that it was not displayed.
It's all part of the digital conference experience that, it's nice we can be at home, but this is part of the way we reach so many people internationally, which is exciting. Yeah. But in the end, we were able to show your screen, full screen on our side. So thank you for that. Dr. Heil, I would like to speak to you about vertical farming, which is what you sort of looked into and mentioned, right? So maybe a similar question, because we're going to get into vertical farming more in the next session, but what do you think about vertical farming in the kingdom? How do you see it playing out over the next 10 years? I mean, I know you're from a research perspective, but I'm just curious what you think of its value for the kingdom.
I think vertical farming or controlled environment agriculture in general, has great potential for the Middle East generally and for Saudi Arabia in specific. As you know, climate condition in Saudi is really tough in the summer. You've got external temperature around 60 Celsius degrees, and this is extremely high. So the being able to control the environment, it has a massive potential. I know it's applied in the West, although, and you've got the nexus between energy and water. So in Saudi, there's not much water, but there's abundant of solar energy, of various type of energy. So playing with this, and the main challenge for vertical farming, controlled environment agriculture is energy. So it provides the potential. There's massive potential for it. Specifically, the water use efficiency in vertical farming can be over 95% with the closed circuit. So I'm very confident. We did a project with Istidama and with King Abdulaziz City for Science and Technology. We grow some lettuce, and the water consumption by plant, it was done by Engineer Abdulaziz As-Sahli and Dr. Abdullah Rajhi, was 1.7 liter per plant, while if you do it in greenhouses and in open field is over 20 liters of water. There's a very exciting project which we are doing with Dr. Abdullah Rajhi from Istidama, where we will be building some vertical farming under the sun, underground, to increase the insulation. So backing to Christine talk and to joke as well, it's finding the solution that fits Saudi and the environment Saudi, rather than just transferring the technology from the West to the region, because sometimes it doesn't work. You need to design something that fit the requirement of that environment. But in brief, I think there's massive potential, and I'm very glad to be collaborating with colleagues at Istidama in addressing some of the challenges at local environment in Saudi Arabia.
Thank you so much. And hopefully your research, which reduces some of the energy rates and optimizes light for vertical farming, could be a benefit to Saudi Arabia as well. So we'll keep watching your research there. Dr. Heil, thank you so much.
Thank you.
Christine, if I could ask you a final question for this session. I don't know if we can bring you up. There you are. We just need to unmute you for a moment. If we could unmute Christine, that'd be great. Let me see if I can do it on my end.
There we go. I think I understood now. Yeah.
So thanks again for your presentation with the live drawings happening. It's all part of the excitement. So appreciate that. I want to go directly into something. I know you're working at Giga on big projects, corporates, investments. I get that. But I want to go a little bit to your past, because it relates to Saudi Arabia in particular, and you still work on this. But the role of youth, right? We know Saudi Arabia has such a big youth population, and you mentioned it a little bit in your talk. But I just want to give you the opportunity to share with us, what is the potential for youth in agriculture, and how can Saudi Arabia make some first steps to capitalize on that to solve these food security challenges ahead?
Yeah, that's amazing. I actually think it is a giga opportunity to really be focusing on them as, a massive resource. I hate that word, actually, people aren't a resource, but I guess, as a massive opportunity for for innovation and actually creating that leapfrog opportunity that I mentioned that Saudi can really step into. So in my work with youth, really all over the world, we see that today's young people are the most entrepreneurial, digitally savvy, purpose-driven generations of all time. And so connecting them into agriculture is an opportunity, but we need to focus on it in a very realistic way, because right now the narrative of agriculture is one that isn't resonating with a lot of young people. They don't understand it. They don't see profitability in it. They don't see opportunities. And so again, I think that's something that if Saudi and the region stepped into to actually show this is a sector rife with innovation. It aligns with your values, and it actually can, we can scale what you build. That's where you can see a huge groundswell of momentum that can create this outsized transformative impact that we're looking for. So I've had the chance, I'm part of the Goombuk Minat Regenerative Agriculture Program, which is actually focused on developing local regenerative, and I just want to clarify, regenerative in terms of outcomes, right? So we're not just focused on like regenerative ag by its specific definition with, grazing animals and soil health. We're looking broadly at how we can achieve regenerative outcomes in the region. And I've had the chance to work with a lot of the startups and research projects that have taken part in that program and really seen world-class innovation coming from the region. And now it's time to shine a light on that, to give them pathways to scale, to show investors that these are real, and that they should be paid attention to. And so I mentioned the automation example in my talk, and I just want to like really quickly highlight that. Aztec in Egypt, right? So they've developed kind of this automatic weeding system, robotic weeding system, again, right sized to the farms and the crops grown in the North African and Middle East region. They're tapping into open source frameworks to accelerate their innovation process. And I think this is really exciting to see something like this. I also worked with a nano encapsulation technology from Kaust. They've gone on to win lots of global awards, but I see the same type of solution coming from the US that's getting hundreds of millions of dollars in investments. So it's like, this is a world-class innovation. They're focused on using nanoencapsulation of bio-inputs, targeting heritage wheat varieties, in Saudi. And so again, let's shine a light on this and invest in it. And that's going to create this cascading effect of showing youth that this is a place where they should take their smarts and solutions to the world. Agriculture is the future.
Yeah, thank you so much, Christine. I mean, youth are really the future of this food system. I know as a young person, I got excited about agriculture. I meet other people now, I'm not so young, but there's such an opportunity, as you said, to get them excited about this challenge and be a part of it. And that aligns so much with the Saudiization goals. And there's so many young people, I think, that I've met in Saudi Arabia and across the GCC as you have to engage in this. If you all want to learn more, you can obviously check out Christine and our various speakers to learn more about what they've done. I'm sure they would love to hear from you on LinkedIn. I know these talks were short previews as we cover a lot of topics. So please continue your research, continue your work, and consider this workshop an opportunity for us to collaborate even after it's done. So thank you so much to all of our speakers in session one. Really appreciate kicking us off there. And now we are ready to get into session two, a topic very close to my heart, which is vertical farming. We're going deeper into that. And we have a really good curated set of speakers from around the world for this. In session two, vertical farming is a technical approach for enhancing crops productivity. Now, our first talk is something that I think a lot of you are really curious about, which is this question that comes up a lot, which is what else can we grow in vertical farms besides leafy greens? And to do that, we are going to the expert on the topic, Professor Paul Gauthier at the University of Queensland in Australia. Paul will be sharing a talk with us about the suitability of vertical farming for staple crops and how this might work and what this looks like in some of his research. Now, as I mentioned, Paul is a global leader in vertical farming, climate smart agriculture. He directs the Australian Indoor Farming Lab. He's also worked at large-scale vertical farms like Bowery. I've been able to visit his research facilities and his labs at Princeton University. And without further ado, how are you doing, Paul?
I'm pretty good, thank you. How are you doing, everyone?
I'm good. It's good to see you. Thank you. We've got a big audience here for you, and we're ready to go. So you've got 15 minutes for your presentation. Thanks so much.
All right, thank you, Henry. Good day, everyone, wherever you are in the world. And it's really great to be back to this conference. So the presentation I'm going to make today is to talk about the suitability of staple crops for vertical farming. It's a long debate, and I think the big question that we all try to answer is one of the biggest challenge of the world today, one of the biggest challenge for the next generation is how could we feed a growing population without impacting our environment? And vertical farming has been presented as one of the solutions for that. And when we think about vertical farming, staple crops are not necessarily the ones that come into questions. But I think what is important is to remember what are staple crops at this stage, right? It's important to remember that staple crops are basically three different categories, and this is not some of the crops that we usually grow in vertical farm. However, these crops are some of the major ones that we need to grow outdoor to feed population. We're talking about rice, wheat, but also soybean, cowpea, and chickpea, which are extremely important in different cultures, especially in the Arabic culture. So I think these are all different crops that could or could not, or should not, be grown in vertical farm. So before I move forward, since I was there last time, I just want to I want to remind where we are in the staple crops today. So the story about staple crops really started in vertical farm, really started in 2010, where Professor Dixon Despommier wrote this book about the vertical farm and how we could grow or use the city buildings to grow food to feed its own population. And the idea was just a concept in 2010. And very quickly after that, my team and a group of people that I put together published this paper about wheat yield potential in controlled environment vertical farm. And this paper have made some impact, and I'm going to talk about what this paper means. But when we look at more recent work from some member of the team that I put together at the time, and now they are in different research lab, when we published the work in 2020, a lot of things were theoretical. Everything was theoretical. We used numbers that were from the literature, and we applied with a theoretical model to estimate what controlled environment is. This year, as I said, some member of this team published a paper looking at what will be the impact of hydroponic on and LEDs on the yield of wheat. The great thing about this paper is they actually demonstrate that we are pretty close to what we said theoretically, and there is a lot of possibility for the future. So let's think about what first the 2020 paper was saying. So the first thing that we were looking at, we took, as I said, data from the literature, from this paper from Money and Bugby, who did some work for NASA and for and growing wheat in space. And when they did that, they had different yield, or they had one yield, and this yield was one of the maximum in controlled environment at the stage. So we're talking about 1990s there. And it was really the maximum yield of wheat that was known at the time to grow in a controlled environment. On top of that, we use the modeling to be able to predict what should be the optimal CO2 concentration, the optimal light. And the goal of that was what could be the maximum yield. And what we got was the theoretical yield could be 39 tons per harvest, not per hectare, but for harvest, for 1 hectare eventually. And then from these 39 tons, we managed to calculate how many harvests per year, which end up to be 5 point something, and then multiply that in a vertical farm. Of course, vertical farm means that you can grow the crop from January to December with no stop, and you can grow it all year long, so you could have more harvest. The main discovery there was, the main outcome was the annual yield for a vertical farm like the one designed in the center with a 10 layer of wheat on top of each other. We were thinking about short wheat here, the one that NASA was using. We'll end up with a yield of 1,940 tons annually, which is significantly way more than what the field is able to produce. It's about 600 times more. But you could see that the amount of energy at the time when we published this paper in 2020 was 799,364 megawatt hour. So it's a lot of energy. You basically almost need a nuclear plant to be able to produce that, or really a lot of solar panels around. So you don't really gain in space because if you think of solar panel, you will have to fill up a major field, like all the fields that you have removed the wheat from with solar panels, and then solar panels have another cost on top of that. So it was very inefficient, and again, it's something that a lot of people have debated. It's a lot of energy, and of course, it requires a lot of things. Now, if you look at what was driving the cost was mainly the energy. You see, it's more than 50% of the cost was energy. Now, we publish at the end this evolution of like what would be the cost versus the return on investment. So you could see that we start in 2020 when we published this paper, which is 2019 year. You could see that it was 49 more than for $1 you get back. You basically use 49 times more dollars. So for $49 you spend, you only get one back. So it was very, very unprofitable to do that. And you also require the price of wheat per ton internationally, if you look at international price, to be much higher than it is today. However, what we have seen is over the past few years, especially in 2020 with the Ukrainian war, that the price of wheat in 2022 went to 446 tons per hectare. When here you could see that we predicted that by 2050, if the price of wheat reach $500 per ton, you will reach about 9-to-1 ratio. So it was pretty interesting to see that, because when the price went up, suddenly it may eventually not still more expensive, but with the technology and everything that we have at the time. Now, here's the thing that is interesting. At the time, as I said, the conclusion of the paper was to reach profitability, we need to improve technology, we need to improve genetics, or have an improved genetics to do that. And we also need the price globally to be escalating. And of course, and one of the things that we mentioned at the end is that it's not going to be a profitable business if you want to be a private company. So government subsidies were extremely important to be involved into it, to be able to decrease the cost of building the facility. Basically, our paper assumes that the cost of building this facility is only, it's very a fraction of what the energy is. And so removing this burden was extremely important, but also subsidies help decreasing the price of electricity. Now, from the time that we published this paper, the efficacy of LEDs, which is the amount of micromole that is able to produce for LED per kilowatt hour, basically, that is used for producing these lights, have been increasing significantly. There's been a lot of improvement in terms of the technologies. The efficacy of LEDs have changed. Today we are about, we are seeing some LEDs that could be 4 micromole per joule, so it's pretty more efficient. So already just by improving the technology here, just improving the light efficacy, you could see that you have 1.5 times what it was at the time of the paper. So when you just apply this 1.5 times to the amount of energy there, you could see that you already reduced to about 200 megawatts for that. It's still way too much, but that's a way of looking at it. And so technology really improved, and then there is a lot of development in that area looking at, how could we make it profitable? Then this paper, basically the conclusion is, as I said, is, growing wheat in hydroponic and high CO2 really increase the yield, but it decreases the quality of the protein. So what that means is that when you are in an indoor setup, because you force the plant to grow so much, then the current genetics that is available, this one was using apogee, you current yield that you get are still much higher, but the quality of the protein is lower. So in terms of energies that people will need to, when they eat it, you will have to eat more to reach the same calorie impact. So that's really, something about this paper that just show okay, now how could we get better genetics? And that's where the sky is the limit. And so, the genetic improvement for wheat is really interesting to look into it, because now CRISPR or advanced technology really push us to push the yield of wheat where nobody have been able to put it before. Because the biggest challenge that we had is, if you look at the slow increase of wheat yield. So this one is it's looking at the region versus the rest of the world, and you could see here that there is some improvement of the yield, but it's still quite low. We're talking about a few tons per hectare of land outdoor per year, and not really like, the 39 tons we're talking about. So the yields are improving outside, but the reason why it's so slow is because you can't control the environment. Now, if you can, that's really help. And you could see that our improvement of technologies in growing it really improve, and the seeds as well. And so we know that genetics can get there. But when you compare, for example, if you think that some traits for the plants are important, you could look at yield versus plant height. And you could see that there is a sort of a correlation, but not that much, meaning that we can improve some part like the yield and without having to have big plants or small plants. And so you could really target some to improve the yield in the direction that you want. And that's, really fascinating what we can do. So genetic can really help achieving our goal, but it will be combined with improvement in technology and production efficiency. And then finally, there's potential, of course, for other staple crops. Wheat was one of them. But we haven't really looked into rice. There is some development now going into rice. And then, by the time in 2023, we'll have a lot of options with soybean and others. And maybe other staple crops will come into the picture, but the price is extremely important there. We won't be able to grow so that's what we looked into it. And I'm just going to skip because I know that I'm at the end of that talk. I think one of the things with vertical farm is that we won't be able to grow staple crops until the price is high enough or until there is a need for it. And especially when we talk about, energy or profitability and everything, it's important. It's a long road ahead for being profitable. Maybe many vertical farms, private vertical farms have tried, but today it's still a dream of growing profitably, wheat or any other staple crops. And we still have a lot of development to be done to reach profitability. And when we think about food security. So with that, it's a yes, but there is a lot of things to be improved. It's a not yet, I should say. So thank you for listening.
Thank you so much, Paul. Always great to hear from you, and thank you for the efficient talk. You covered so much related to this question of staple crops and vertical farming, which is honestly something that we're getting a lot of questions about from Saudi Arabia. And I think it's a topic that you can see from the reactions, a lot of attendees are interested in. So really appreciate that. You can stop sharing your screen there, and we're going to keep you around for the Q&A period on this topic coming up a little bit later. But next up, we're going to go deeper into this topic, and we're going to speak to or hear from Dr. Atif Sharif. And Dr. Atif has a number of roles, from CEO of QCM/Nexus. He's in Saudi Arabia and China. We'll maybe hear a little bit about that. He's going to speak about the energy and resource efficiency and high density vertical production of staples. If we could pull Dr. Atif up and have him share his screen, I'll begin by giving you a little bit more background on his experience. So it's Qayyim Consulting and Management Company, QCM. This is a Saudi-based consultancy and management firm actively engaged in transferring and localization of know-how to contribute to Vision 2030. Very, very important. And he's got over 40 years of experience across many industrial sectors, including agriculture. Dr. Atif, are you there?
Yes.
How are you doing?
I'm doing well. Thank you very much for the opportunity to meet our colleagues here and the attendance of this magnificent workshop. Allow me to start by a small video about the Nexus project, which we will be talking about. So I'll play it. I hope that
Let's test the audio first. Let's play it and see if the audio went, because we had a challenge with the last video. So let's just give it a test. Yeah, I think the audio is.
In remarkable agricultural feat, Chinese scientists recently harvested the first crop of fast-ripening rice cultivated in desert greenhouses in the northwestern Xinjiang Uyghur Autonomous Region. Researchers with the Chinese Academy of Agricultural Sciences say it took just 2 months for the rice to mature, which is about half the time it takes for traditional rice.
What we adopted is the rapid breeding technique, in which we spent 15 days in cultivating rice seedlings. We transplanted the rice seedlings in these soilless tanks in February, and by now, the whole growth cycle is 60 days.
Although speedy rice maturity has been achieved at plant factories in other parts of the country, this was the first successful test of the techniques in a climate-controlled environment in the desert.
Under the conditions of our plant factory, we could completely control the temperature, humidity, light, carbon dioxide, and nutrition around the rice roots. That means we could completely control its environment. However, in the environment of the plant factory, the costs of energy, operation, and construction are rather high. That's why we want to utilize the greenhouse conditions in desert, because the light and heat resources are ideal in desert greenhouses.
Researchers say they're trying to replicate their success with other crops, including soybeans, corn, and wheat, all of which will be grown inside desert greenhouses using hydroponic farming, controlled temperatures, and artificial lighting.
That was just a short video about the Nexus project. I'll go straight to the presentation.
Excellent, thank you. That was very interesting. We're looking forward to hearing more.
Can you see my screen?
It's loading. We'll give it one more moment as it loads up. Yeah, and then just click that. There you go.
Is it full screen now?
Not yet. It seems to have a bit of a delay, but if you want to just click on that button again, let's see. Still not full screen. I can't see your cursor moving there. Would you mind trying? Okay, there we go. Something's happening. There, we are in the speaker mode again. Let's try and fix this time. If you go to display settings at the top here.
In my screen, it shows full screen. I don't know.
Okay. That's because it's on the speaker mode, but let's give it a try. Our colleagues were able to fix it last time for our other colleagues. So let's continue with your presentation. It's a little bit smaller, but I think it'll be okay. We have about 10 minutes. Okay, Dr. Atif, please.
Yeah, sure. Let me talk about Nexus as a solution. It's a solution developed by a network of research and development centers in China, led by BAFS, which is the Beijing Academy for Agriculture and Forestry, by the Institute of Urban Agriculture. So more than 35 research institutes are participating in this. And the idea is to try to get the best quality, the best yield in unconventional environments, such as the environments in Saudi Arabia. As we heard from previous speakers, this is a fully controlled system where the smart management of the whole operation is there. So it integrates the hydroponic, aeroponic, recipe substrate in the system, so that we can mainly improve the yield. And the yield in some of the crops were the Nexus system was able to increase the yield by 6 to 8 times. The main thing, as you can see from compared to the conventional rice propagation. If you look at how the system was able to shorten the time so that the number of harvests are increased and the yield is increased. One of the most important things that is really of great interest to Saudi Arabia is the water conservation. The system can save about 90% of the water, which is a great when we consider that many of the Saudi Arabia water resources are non-renewable. So the system can go from medium tech to high tech, whereby full utilization of smart irrigation, smart controls, even robotics can be adapted to the system. As you can see from here, the system can reduce very much the pesticides that will be used. The nutrient value of the crops can be controlled to ensure that the crops will have the nutrient value required. Basically, the system utilizes advanced lighting system throughout the whole process of this agriculture. As you can see from the table, as a comparison between the conventional growth days to the speed breeding, with rice, we're reducing the time by 53%, with wheat it's 63%, and many of the crops that have been tried, you can see that there is a substantial saving in time, so the time reduction can help advance the yield, and the water consumption is very low with this type of crops. It is very critical here to regulate the light for the crops, and for that the system has allowed the use of both natural light and artificial light as well. As you can see from the photos, this is in Chengdu, whereby it's an arid climate, desert, but yet the utilization of solar energy, renewable energy, plus the light and the artificial light is a combination that drives the system to becoming more feasible. If you add to that the AWG, atmospheric water generation equipments, that will do as well a substantial saving in water as well. As you can see here, the propagation and production accelerators, there are varieties which makes the system suitable for small-sized projects and medium-sized projects and big-sized projects. And with that, when we talk about small-sized projects, it is very important to try to draw in the young people into the agriculture business, and with the applications, the vast applications for the system, there are many ways that you can have small projects run by young Saudi men and women. If we look at some of the advantages of the system, we see that it offers shorter production time, better yield, less water, less pesticides, less fertilizers. It offers definitely, and this is what QCM is focusing on the know-how transfer and localization. It's not just the transfer, but we make sure that whatever technologies are transferred are suitable for the Saudi environment. It's environmentally friendly, scalable, and controllable. This table shows the water usage and the yield per hectare and the number of labors needed. The comparison speaks for itself about the system. The cost efficiency of this project is illustrated. I know that the 15-minute won't be able, but I'll be more than happy to share a full presentation, more information for whoever likes to contact us on this. I hope that I'm on time on this.
Yes, you are. You're exactly on time, Dr. Atif. Thank you so much. And that was a lot of information, and we're going to have some follow-up questions for you. So please stick around. But thank you for that. Very, very interesting presentation. Really appreciate your time and being on time. And we've already heard from speakers in 4 continents, and we're about to add another one here as we head over to Japan for our 3rd talk today from Miss Eri Hayashi, who is the president of the Japan Plant Factory Association. And Ms. Eri Hayashi is going to be speaking about integrating water, energy, and nutrient, the WEN cycle for sustainable agritech solutions, and talking to us a bit about plant factories. And just as some background, for those of you who don't know, vertical farming really commercialized first in Japan in the 80s and 90s, long before we saw it in Europe and North America. So there's a lot of knowledge that we can gain from Ms. Hayashi and her organization. How are you doing, Eri?
Hi, good afternoon and good evening, actually, from my side. Very happy to be here. Thanks.
I'm here in New York. It's the afternoon in Saudi Arabia, and it's probably evening where you are and where Paul is. So we're all joining internationally to share knowledge. But so good to have you here, and please, we look forward to your presentation.
Thank you very much. First of all, very grateful for this great opportunity, and I'm very happy to speak about integrating water, energy, and nutrient cycles for sustainable agri-tech solution. To start with, I'd like to share a little bit about our organization. Japan Plant Factory Association, JPFA, was founded in 2010 with a mission to develop and also introduce the sustainable plant production system with a collaboration with academia, industry, and the public. So we try to do the applied research together with research institute and then also the companies and then also public on the campus of Chiba University, and then try to introduce to the society. So in the city that we are located called Kashiwanaha, it's a smart city. So not only research, but actual commercial production is going on in the different sizes and a different purpose. So it's a very interesting smart city that on the vision, with a vision of staying healthy simply by living. So we are more than happy to invite you to the upcoming international event to Kashiwanaha this summer. And on campus, so this is like a showcase of housing, so different research topic using the greenhouse and a plant factory vertical farm, working on the sustainable plant production system, namely like automations or indoor breeding projects or phenotyping or other various crops. So for example, for seedling production system using the indoor production system that you grow the young plants, but then transplant into greenhouse, or for example, the spinach production system. And then also the other projects including using the fine misting technologies to control the environment, but also applying the mist to the root zone so to control the functional components. For example, by controlling the environment, you can have high GABA content tomato, for example. And also tomato, not just using the runners, but using the seed propagated strawberries. There are projects on growing strawberries in indoor plant factory and then also greenhouse. So there are great opportunities that you can explore the Japanese variety in early March. Okay, so the plant factory vertical farm, as you're all aware, that have a potential to contribute to solve the global major 4 issues at the same time, including the food, energy, resources, the environment, and also improving the quality of life of people. But that's also the important thing is that with this technology, we can also grow the safe and secure the functional foods and with a highly resource efficient way. The biggest feature of plant factory is that it's the cultivation room is almost highly airtight and assembly insulated. So it's almost the closed environment. So with that, it's really easy to visualize input and output or even the waste, and then also analyze online, like a time series analysis. So, and then also, it makes us very easy to analyze and getting the time series data with phenotyping, and then so you can have a predictions of the growth analysis without any complicated model. So the simple example is that with just simple sensors, you can visualize speed of photosynthesis, net photosynthesis, or water uptake rates, just calculating in simple way. So not only getting the state variables like temperature, humidity, but getting the rate variable, the speed of the actions is quite important. But our goal is not just to visualize that, but also our goal is for sure that controlling the environment, having the goal of what kind of phenotype you want to have, and also considering the market situations or electricity price rate, for example. So for us, using AI is quite promising because there's so many variable and combinations. So I'm very positive that with the help of AI, this technology is going to be expanded quite fast. And then also with this closed environment, so there's evolutionary features enabling continuous productive improvement that observability, traceabilities, controllabilities, and reproducibilities, and predictabilities. Okay, so you can see here the main component of cultivation room of plant factory vertical farm, integrating water, energy, and nutrient cycles. So with the semi well-insulated, airtight warehouse-like structures, with the LED lighting, the hydroponic cultivations, and nutrient solution supply unit, is a closed loop of the production system. But speaking of waters, as you can see here, the plants actually absorbs water by roots, but then 80% or 90% of the water actually transpired by the leaf. And since it's closed environment, the air conditioner capture the drain water, so you can actually recycle the water, so that you can reduce 90% of the water with this system. And this is the table of comparing the resource use efficiencies of the greenhouse and the plant factory. And then here is the theoretical maximum value. So as previous speaker has indicated many times, the energy is quite challenging now here. But I also wanted to highlight these figures that fundamentally is quite not efficient way to grow plants using the energies and lighting, electric lighting, because it's just a 1% of chemical energy fix out of the electric energy consumed. So fundamentally, it's a very challenging way to grow plants using the electric energies. So that's really critical that how we have higher efficacies of lighting, but also how you utilize the light to grow plants and deliver light for each single leaf in the three-dimensional way is very challenging. And speaking of the electricity consumption by component of the plant factory, so for example, if we have the coefficient of performance of HVAC, if it's 4, which is relatively okay number, the electricities go 70% go LED light and 20% go air conditioner and 10% for other pumps and others. But so if we talked about how we deliver the system and then also how we actually develop the sectors, that is always these questions. So how we develop the market is quite challenging. So we always receive so many questions why the Japanese companies, there's some companies up and running more than 10 years. So this is the simple answer. So first, we need to have a factory design incorporating engineering consideration for factory specification. That's the basics. But also the good factory actually work on improving the daily productivities every day. And then also understanding the market and always improving the quality of product development. And then also the developing the market channels is always the best and the must-have package. And speaking of the Japanese industries market, so it's an industry starting in 1980s. And then after that, using the fluorescence lamp 1990s, multi-layer production started. And then after 2008, the more companies started to use LED. So roughly speaking, there are 200 commercial plant factory up and running in Japan. And if we look at these figures, more than 80% of the companies using the white light now. And then recently, the scalability is happening now, so that the mass production, if you have a mass production, you can also sell the produce to food service, not only to supermarket. So there's some convenience store using the plant factory produce to sandwiches, salad, or some bread, national chain, or for example, cake using the strawberries. So for example, this company called Vitek is selling the 5 tons of lettuce every day nationwide to a convenience store or nationwide retail or other companies. But as you know, you can see the majority of the company selling the leafy lettuce. So that, of course, the diversification of commercial produce is crucial. And also the renewable energy is also challenged now, so that how we store the energy in the very cheap way is critical now. And this is the rough breakdown of the cost that, energies go less than 30%, and the labor and depreciation is the major cost. And another example is the 808 factory based in Shizuoka Prefecture, producing 20,000 heads of lettuce. Actually, you can see this shiny floor. So hygiene management is also important if you deal with the food service. And then also the sensing is quite useful so that you can improve the productivity daily, and then also you can guarantee and then prove the cleanness and quality of your produce. And then also they have a camera so that tracking even single hands of each worker so that they can check the cause and effect of what if it's happened in the historical timeline. And this is the number of the productivity by resource applied. So that's the good example of the major Japanese companies. But also, this is the reality of the actual company of ADOA factory. So, so you can have a higher number, but actually, your customer actually ask you to have smaller plants, or if you have a different varieties, you can have a different numbers. And okay, and then also if you have bigger plants, so you can actually reduce the labor cost because you can sell the produce. So that this is an example of how you reduce the energy cost, so that simply by checking the electricity consumption, and they can reduce 30%. So Harry, I guess I have just 1 minute.
Yes, let's give a final statement and then we'll get into questions.
Okay, all right. So I guess I have too many slides, but my point is that we need to work on the phenotyping, like sensing, so that we can actually track the history of plants to understand the cause and effect of the environment and also what's going on with plants. And then also the biggest merit of this technology is that we can share the data and you can analyze from different angles based on what your expertise is, so that you can do the same experiment again. So I think I'm quite positive on, I actually believe in this technology and achieving the resource autonomous plant factory. And then also I think I personally want to do this research also to integrate with medical field, that what's the impact of eating these plants, and also what's the impact of the environment. And then also I think with this technology we can achieve the distributed farming system, and and then you can actually play around with the data, and you can have a healthy life with a plant-based entertainment. So I think it's quite interesting. Society is gonna be coming with us. So thank you very much.
Thank you so much, Ari. And we can invite the other speakers from this session to come up for the Q&A period. So they'll join momentarily, but Ari, let's just continue. Thank you so much. It's so great to have you here with all your experience. I just want to share with our audience a little bit more about the Japanese Plant Factory Association, and how many vertical farms are there these days that you estimate in Japan, for example?
Well, it'll be more than 200.
Yeah, so that's a lot. I think a lot of people don't realize that there's that many, and I know they're varying in sizes and types, but I think that that's very interesting for people looking to get that knowledge. And that event you said, which is an event at Chiba University, is happening August 31st, where people want to get more in depth and into this topic as well. I guess on that context, with what Japan has done, you mentioned the market conditions being so important. You mentioned the good engineering of the plant factories, but what other guidance do you have for a nation like Saudi Arabia that is pushing forward to lead from an agriculture technology perspective and sees vertical farming as a part of it, or plant factories as you call them? What are some high level advice that you would sort of share with the country of Saudi Arabia, the kingdom, related to how they can foster a thriving vertical farming sector?
Thanks for the great question. I think, there's so many research have done internationally, including United States and other countries. So I think international collaboration is really a practical way to start with. And then also you can fine tune what is needed in the kingdom, I think. But also like using this technology, the global technology, but also growing in the local crops and what is needed in local is also crucial. So I think it's almost like the iPhone, the smartphones. the industry. So that using the international technology, like common technology, but also the application is based on the local needs and what you like to do. So I think mixing international platform, but also really what is needed in the local is also more important actually. Considering the culture. Appreciating the
comparison,
culture.
Right? And I think you mentioned it, right? So in Japan, consumers are more comfortable with a smaller product, right? A smaller lettuce product that allows the vertical farm certain advantages. In Saudi Arabia, they maybe need something different. So you have to customize to match the market, match the technology to the needs there as well. Well, thank you so much, Ari. Are you there? Paul, I'd like to ask you some questions as well. Let's see if we can pull Paul up. And we can keep all the speakers. We have a bit of time this time around, so if we can have them next to each other. Hi, Paul. So, Paul, I want to ask you a similar question, but in the context of the staple crops themselves, right? It was so interesting what you shared about Dixon's vision and your research related to staple crops, the importance of it. And there's sort of this impending future where the climate change effects or even other shocks in the system like we've seen has occurred with wheat supply could happen, and the importance of growing more staple crops even in extreme climates like Saudi Arabia stands up. So if we were to go back to the same question, how would you encourage the Kingdom of Saudi Arabia to engage in research or commercialization of these staple crops and vertical farms to sort of get ahead of what might be this slightly concerning or very concerning inevitable future where we need to grow more of these staple crops indoors? Where would you begin? What are some things that you would encourage the kingdom to focus on?
Yeah, I think thank you for the question, Henry. I think it's a very relevant one. And it's relevant not just for the kingdom, but for everywhere in the world. I think the big thing about vertical farm is it's important to see that it's a new industry which is emerging, and we need to build the industry and everything around it to be able to be successful. And at the time, what we are seeing with vertical farm is it's kind of like it's a small village trying to fight an entire world, and it's impossible to do that because every single vertical farm are very much isolated. When there is an entire business around it, the agricultural field have already this decades and century of establishment of agriculture behind them. We don't have that in vertical farm. And so to make it successful, you need to think about what kind of infrastructure we need to get, transportation and supplies. I think, it's as ridiculous as where do I get my seeds from, right? Mm-hmm. And it's just like, in many other countries like the US or in Australia, it's easy to just go online on Amazon and order some seeds and you get them the next day or the day after. But, in Saudi Arabia, there could be some limitation where to get the plants. I think the big example, and, Ari just talked about strawberries, is where do you get your plants from? You can't, some of them can be shipped, but, there might be some quarantine restrictions. So there is a lot of things that you need to deal with around to make it successful. And so the big target is really to see it as an ecosystem and to build this ecosystem before even investing into the vertical farming.
Yeah, it's such a great point, right? We have to invest in sort of the culture of agriculture, right? The foundational elements that we need, the systems, the infrastructure to be able to prepare for these inevitable challenges. Thank you, Paul. I might come back to you again in a moment, so stick around. Just a reminder to all of our participants from around the world, especially those who speak Arabic. We have an Arabic room here. If you go to the 3 dots called More, you can then select Arabic and you'll hear the translation live in Arabic. Just another reminder there. And I've been told that we can accept some audience questions in the chat. We'll be selective about it, so feel free to drop questions in there. We won't get to all of them, but we may pick some of the best ones for that. Dr. Atif, are you there?
Yes. Yes, please.
So let's go over to you. Your talk was also extremely interesting and focused on this China-based project with the high density staple production, right? And with some really exciting results. So, my question is a bit different from the others, but how would you transfer that? Obviously, you're a bridge between Saudi Arabia and China, so you're potentially the best person for this. But how would you bridge that experience to Saudi Arabia and its climate, which is probably quite different? correct me if I'm wrong, but it's probably quite different from the site with the images you saw. But tell us about that. What does that look like to grow staple crops in high density greenhouse environments in the kingdom?
Let me start by saying that, what's interesting about any cooperation with Saudi Arabia is that the Saudis know exactly what they want. They have already a vast experience throughout, tens of years. The agriculture has always been an advanced, we've used the advanced irrigation systems probably for the past 40 years. So a lot of technologies has been tried. When we picked the Chinese, it was mainly because the environment that they have conducted all the research were desert environment. And that was something that we started with. And throughout the experience and the what they have done, and as we know today, the Chinese in terms of the technologies are advanced. I wouldn't say, and even them, they are not claiming to be the most advanced, but they have already accomplished a lot in this field. So when we started talking to BAFs, we found in them a spirit of cooperation, the flexibility on what type of crops we want to grow. So we have identified that, two crops to start with, which are the wheat and probably surprise to some the rice as well. So hopefully we will start to have a Saudi rice. We produce rice in Saudi Arabia in the eastern province, but only on small scale. I mean, compared to the needs of the country, it's just a very, very tiny portion of what Saudi Arabia needs. So when working with someone who understands and have a plan, all of you have heard about Vision 2030. When you talk about Vision 2030, which is a comprehensive transformation plan, and when you talk about the Saudi strategy for agriculture, for food security, you find that all the aspects of, digitalization, the proper planning, the PPP, private-public partnerships, the platforms are already there and they are advanced, which make Arabizing technologies. I said it's not just about transferring technologies. It's the localization of the technologies. The number of experts, if you look at Istidama alone, the number of experts and the quality of expertise they have makes it really wonderful to work with such entities and make make results to speak about itself. So
I agree with that. Yeah, really such talent and an opportunity there. A couple of our speakers talked about genetics, right? So Paul, you mentioned that a little bit, and I know Ari, you've spoken about before, Dr. Atif as well. So I wanted to ask a little bit of a question about that. I was at an event once, and one of the speakers said that genetics was like 70 or 80% of the problem, right? And so we talk about all these technologies we're building around the seeds to grow plants in all these environments, but sometimes we focus a little bit less on the genetics. So I wanted to, answer this question that came from Christine Gould, and it was a similar one that I had. Let's talk a bit more about the role of genetics, Paul, and any other speaker can join in on this question as well. Why does it matter so much? What are the key opportunities in this? What are the changes we can actually make with that? Paul, do you want to go ahead first?
Yeah, for sure. I think the big thing with genetics is we need to be able to identify what traits we want to breed for or to select for. Genetics is extremely important, that's for sure. But what we have been seeing so far is people are using, seeds from plants that have been grown in the field. And in the field, we mostly breed for resistance, yield also, but usually there is a threshold. You could get high yield, but not very high resistance. And so you have you need to weigh which one you want more, and you need to make some concessions there. And so the big thing with genetics is, yes, you could totally breed for indoor farming, and but we need to figure out what traits we want to breed for. I show the graph about the height versus the yield, and because height is very important in a vertical farm. And today we have the tools to be able to breed into the direction that we will get plants. I think the question from Christine was about, few leaf or few roots, or I think it's maybe all of the above or none of the above. It really depends on the situation. We don't really know how the plants are going to react indoor. We have to remember that most of the crops that are in the field were bred for resistance and not necessarily for an environment or climate, pesticide-free, or fully in what, like for the rice, yes, fully in water, but they're still in soil. Now you could grow them without soil. So there is an entire knowledge on the plant physiology itself that is required before we can even go into the genetic part of improving in that aspect. So there is, yes, genetic is part of it, but I won't say it's 70%. I think there is some papers that just show that recently, and I will say it's not necessarily 70%, but at least it's 50%. And 50% is to understand how the indoor environment influences the physiology of the plant, which so far we don't know. We know how the environment outside, which vary a lot, influence the physiology, but not indoor. Indoor, we push everything to the extreme.
Yeah. Super interesting what you said, right? And like that we're growing these plants that were for outdoors, we're growing them indoors, and anything for outdoors is bred for like you said, pest resistance, and indoors we don't need that because we're protecting the plant. So I suppose the need would be energy reduction and density, right? Plants that can grow with less light, plants that take up less space can still produce that value, or some of the dietary focus that Christine mentioned. Paul, one more question here, just here quickly. Are you aware of any private companies that are moving on with this? I know there was InFarm before that was testing this. I've definitely seen it in research context, but are there any private companies that you're aware of that are exploring the staple crop production that you could share with us?
Yeah, so I think, Fisher Farms was exploring in the UK. They were exploring the wheat part as well. As you said, InFarm did that. I think the problem with private is, as I mentioned in my presentation, is the energy part is killing everything. We need to remember that most of these staple crops are starch-based grain. And so you need a very long time to grow them to grain. And during that time, it's not profitable. And then the grain itself requires a lot of energy. Starch is a lot of carbon put together to create, the seeds of the grain. So by default, the amount of energy required for it is very high. So private company today, I'm sure there's companies that I'm not aware of doing it, in the background or trying to do it. But to make it profitable and to make it a profitable business, it's almost impossible, I will say. So, I don't know any other company that have done it, but, they will pop up in the news at some point. Yeah.
We sort of need a new era of vertical farming, hopefully coming soon with some of the challenges that are faced globally. Ari, in Japan, because this is an interesting topic for Saudi Arabia, right, especially. So are there examples of staple crops being commercialized at all? I know in Japan, one of the reasons why plant factories, based on my research, accelerated was because there was essentially a limited forest that was available, and arable land was limited. And so there was a need to sort of innovate and grow more in less space to protect all of the important nature on the highly populated island country of Japan. This was one of the catalysts, right, in my research for plant factories in Japan. But that sort of relates as well to staple crops, right? They take up space. there's a cost to importing them, et cetera. But is there anything happening in Japan that we can look to for inspiration and knowledge on this?
Yeah, sure. So the pharmaceutical productions using the rice has been done like more than 10 years for the research projects for the vaccines. And there's many more company actually working on with a dwarf, like a short rice for not, just a fresh, like a rice, like to buy for the, the crops, but also for other, ingredient to apply for other sectors. But I wanted to highlight the genetics part, but also to touch the genetic, but before, like there's so much space to control the environment, space to control there's, if you have the same genetics, there's the capacity the same, but there's some space to be improved using control the environment. But also after that, if we control change the genetics, then you have higher capacity for the specific trait. So I think with plant factory botanical farm, one of the major things is that you can have a speed breeding, and also the selection is ideal. So if you change a specific trait, but you can have a faster breeding. So I think it's quite interesting topics that we work on together, I think.
Absolutely. Now, Ari, I wanted to take a moment to talk about something you mentioned at the end of your presentation as we were a bit rushed, because I could tell that you're passionate about it, which is the idea of bringing distributed sort of smaller farms into our cities, into our healthcare, into places we live and work. And Japan, certainly has had examples of this, including there was one HQ office of an HR company that had a rice field in its lobby, for example, to show the technology. But maybe this is really interesting as well for Saudi Arabia, because certainly at Agritecture, we're working with a number of master planning of new cities as part of Vision 2030, right? They're designing their own future, whether it's NEOM or whether it's multiple projects that PIF is funding across the kingdom. And these are opportunities to design the food system from the beginning that I find very interesting. So maybe share with us, what is your vision of a city that integrates agriculture into that we could think about as we have this opportunities that are unique to Saudi Arabia to plan new futuristic cities?
Thanks. I think with the technology, you can actually connect with no matter what you do. Like, you can involve with educations or research or breeding or like commercial productions, and you can actually connect it with the data, and that's really aligned with the smart city or city planning platform. And then I think you can you can have a healthy life, and then you can have a different type of the communications based on the plants. So I think it's really go well with the kingdom, and then also especially considering the next generation smart city planning. I think it's just everyone can be involved for the food production, and also you can learn from it, and you can have a connection even different way. With professors or kids or anyone or hospitals and.
Yeah, there's a lot of data about how it speeds up healing and engages young people in education. So I really want to thank our three incredible speakers from around the world here for session 2 on vertical farming. Thank you so much, Dr. Atif, Ari, and Paul, for joining us virtually here today. We are about halfway through our 3rd digital conference here, and we're going to give you a short break. So at 30 minutes past the hour, we're going to start again. Right now, you can stretch, you can get some water, you can take some notes and reflect on what you've learned. But thank you to our speakers so far and all our participants. We'll be right back.
Okay, thank you again. I will continue my presentation. I'm Wang from Nasia, and today I want to introduce about the robotics. So the first is about the background, why I conduct the research in robotics. The first is about the aging problem and labor shortage. Here are very common, the two examples that show the pumpkin harvest and cotton cultivation. So we can see we need a driver to drive the tractor, and there are many people to follow the tractor. They need to conduct a lot of manual work. So it's low efficiency, and it's also time consuming and also dangerous. That's the reason why we need to use the robot to relieve the farmer from the tedious work. And therefore, in our team, recent years, we conducted the overall crop production solution for sustainable agriculture. For example, I will show. We have the 4 target of user group: the government, internships, cooperative, and farmers. And we also developed the unmanned sensing and execution farm equipment, and also AI and robot agricultural foundation model and agricultural knowledge base. And also there are some for the rice and wheat and the soybean and a lot of the crops. So first about the robotics in crop sensing is phenotyping I want to talk about, because the excellent variety contributed more than nearly half to Chinese grain production increase. And also the high throughout data collection and is very important for the breeding. And we can see for the plant phenotyping, the overall life cycle of the crop from the seedling to the mature, we have the different scale and different feature and different source and different environment data. So it's a big data we need to handle. Therefore, in our group, we first developed a multi-sensor array and a generalized imaging box. It integrates many sensors in a minimized form. And the UAV can be attached to the UAV and synchronize, collect, and register multi-source data, such as LiDAR imagery and spectral data. And we also developed the rail-driven plant phenotyping platform. The platform integrates various types of equipment and collect the high through the metadata in the same time. And we also developed the pipeline platform phenotyping platform. It means the sensor is still and the crops go into the equipment and to take photo and like scan. And the rail driven, it means the plant is still and the sensor moves from one side to another side zigzag to conduct the zigzag movement. And also we developed the plant phenotyping robots. We use the UGV and the robotics. UGV means unmanned ground vehicle to sense the crops in open field. And next, I want to talk about the robotics for the open field. Here is the common robot tractor. We modify the traditional tractor into robot. We need to attach the GNSS antenna on the top of the roof, and also we need to use the IMU, the inertial measurement unit, to measure the gesture of the robot. And we also attach the laser scanner and all the camera to the robot. So here we can see it's for the robot, we need a control PC, and we need the field map and many control algorithm and sensors to detect the environment and to detect the position. And then we can get the speed and the desired steering angle. Also, we have the remote control farm management system, which is named Farm Management System. It means the farmer can work in the office and control the robot remotely. So here I want to talk about the field map first. So if we want to get the accurate and efficient map, we have 3 ways. nowadays, we use the handheld RTK GIS to measure the field ground manually. And also we have the second way is the vehicle-mounted RTK GIS. RTK GIS means the centimeter level positioning accuracy. We use the vehicle with the RTK GIS to measure the field boundary and get the accurate field boundary. The third is also the research I conducted in the recent 5 years. We use drone to detect the field and to get the field map. And we developed a semantic 2D map of for example, this is a paddy field. We can get a very accurate ortho image of the field. It's about in millimeter per pixel. Therefore, we developed AI, interactive AI, to segment the field, the obstacle, the entrance, or the exit of the field. And then we can get a very accurate field map. And also, we also developed the field map for the cloud points in the 3D map for path planning. So based on this field map, we can design where to go, where the barn, to assign the tasks to the robots. And the next is about the path planning. The challenge is there are two challenges. The first is complete coverage path planning. As we all know, the field shape is different, is irregular, so it's very difficult to cover the whole field. And the second is about headline turning. So in a small headline, for example, this is the irregular field, and we need to cut the field into different pieces and to design the biased working direction and the number of the path and also the order of the path, which means strip routing planning. Then we can design generate the headline turning. For example, here we generate the several parallel paths, and at the headline, each headline we need to generate the headline turning path. So here is the human-like the driver, they turn from the right side and go reversely and then step into the next path. And then this is the overall map of the robot tractor. So here are some typical headline turning, with a U-turn from one path to the other side, to the other path, with some skips. And also the reverse turning. Reverse turning means the tractor can stop and go reversely at headline. So for example, this is the fishtail turning, also called switchback turning. This is the circle back turning I developed 10 years ago. We can see this one is like this fishtail, and this one is more like the manual drive. It is more efficient and very quick to get into the next path with the same speed. In recent years, we have developed autonomous navigation system, which has been widely used in China and also abroad. It is equipped with the BDS, is Beidou navigation system, which are also called the campus navigation system. And we modify the tractor into robot, and we can draw a lot of conduct the robot art, and we can do the multi-robot cooperation. And also, we also developed the much higher level autonomous navigation system with the safety sensor, including LiDAR, camera, and alarm system, and also the remote control system. Here is an example that we developed. This is the compact agricultural robot. It's electric powered with 6 hours continuous operation capability. And it is universal robot and can be used for the weeding and like the spraying and land leveling. Here is some example that I want to show you. And this on the top is the light and also alarm. The blue device is the antenna, one antenna, and here is the wheel type robot, and it's cultivating. It's a rotor. And here is the weeding as a mower. if the robot go reversely and with the mower attached, it can read the high crops and the weed, and it can also conduct the reading smoothly and precisely in the greenhouse or also in the open field, and also ditching compared to the traditional tractor. This small robot tractor is more compact and friendly to the soil, and it's not like noisy. And here, at last, I want to show two representative cases. One in the greenhouse. In greenhouse, we integrate all the agricultural machinery and agronomy, from the graft to sort and planting and inspecting and transfer harvesting. We have conducted the overall unmanned solution for greenhouse. For the open field, here is an example in paddy field. We have developed the smart agriculture control platform. In this platform, the farmer can manage all the devices, for example, the IoT devices, all the agricultural machinery, and to detect all the camera CCTV and to check the pest and to control the device remotely. So here are my introduction to the robotics in harvesting and crop maintenance. For any query from Saudi Arabia, you can contact me or Dr. Atif. Thank you. Thank you very much.
Thank you so much, Dr. Hawang. Very, very interesting range of robotic solutions that you shared with us, and we'll be asking you some questions later on, so please stick around. Next up, as we continue on this journey of digital infrastructure, we're going to hear from Mr. Tanzer Bilgin, who's the CEO of Doktor Technologies based in Turkey, a really interesting organization that I got connected with not too long ago. And they have some exciting work across the region to optimize irrigation. We got some questions from the audience on that as well. So he'll be speaking about AI-driven crop management systems to optimize yield and also to detect stress/disease in real time. How are you doing, Tanzer?
Great, Henry. Nice to be here, and thanks for this opportunity.
Thank you for joining. We're happy to have you here. If you want to pull up your slides and test that out as we get things ready. And just to our audience, at the end of this session, we will have a Q&A. It's a little bit tight, but if you have questions, you can drop them in the chat. I can't guarantee I'll choose them, but we will pick some of them as needed. Go ahead, Tanzer.
Yeah, you have my screen, right?
Yes.
All right, great. So, in 15 minutes, I will share with you 4 distinct areas of agriculture and what we do with AI-backed algorithms. Mainly what we are doing and where we are leveraging AI is in irrigation optimization is a priority for our clients. For broadacre crops, we offer the crop progress monitoring services, and mainly for the vegetable crops, disease forecasting and spray optimization. And recently, we have started working on red palm beetle early detection system. At the end, I will mention on this one. So we can start with the irrigation. Here I mostly I will mention the systems either to be monitored by satellites or by some sensor networks. But sorry, for the for the irrigation optimization, we in the Middle East and Northern Africa, we work mostly with pivot owners, and there, via satellite images, we can identify the water stress areas. So they're based on the data we provide. They can check in their pivot irrigation systems whether there are some nozzles are leaking or blocked by some debris. So that's one of the aspects. And for precision irrigation enabled pivot systems, we can provide a precision irrigation map. We can also provide this service for broadacre vegetables, which is irrigated by drip irrigation systems. we can offer a similar service. Like we can identify via satellite images where there is a water stress and unexpected slow progressing crop. On the sensor-backed ones, we have been working with Saudi date orchards for 2 years now. And we are deploying 9 centimeter long sensors beneath the date trees. And the AI algorithm there automatically identifies the water soil capacity, where the soil moisture holding capacity we can identify automatically. And based on the differentiation in of soil moistures of different depths, we can identify active root zone. Based on active root zone, we can then replan the required irrigation amount. And the system, we also use AI in identifying the kind of soil structure and drainage speed, which is important in deciding on total irrigation time. So that's how we use AI in irrigation optimization. In the crop progress monitoring, what we basically do, we again leverage satellite images, but our company is a 15-year-old company, and we have been working with satellite images for the last 10 years, and we have a extensive database of individual crops NDVI signatures throughout their growth cycle. So for each crop in different seasons and with different temperature patterns, we have expected some kind of expected NDVI signature growth. NDVI translates the kind of biomass or energy production capacity of the plant. So for each phenological stage, we have a kind of expected level of NDVI amount. If the crop is below that amount, we can tell the client that it's progressing slower than anticipated for that particular time at the season. If it's performing better, we tell them it's overperforming. On the other hand, we do not only provide crop progress monitoring, but scouting, especially the digital intervention in scouting, is also important. We usually work with farms with more than 5,000. With more than 5,000 hectares, and if you manage this massive size of farms, you need to understand what's going on in your field so that you can direct your agronomy team in an intelligent way. And here we use AI to identify the acute problematic zones. If you are familiar with, most of you are, of course, in agriculture, all fields have some chronic low-performing zones. This can be field boundaries, or this can be some structural zones within the field. The thing is, the algorithm we have developed is we can identify the acute, the newly and unexpectedly low-performing tiles within the field. For that sense, the algorithm automatically takes the last 5 years images and creates a chronic low-performing areas, map that on the field, and the new low-performing areas, if they do not overlap with these chronic ones, we identify as the acute problematic zones, which is a very useful service for big-scale farms, or even for the contract farming companies. For the disease risk and smart applications, most of our clients in disease risk alerts are either orchard owners or vegetable growers, because most of the veggies and the orchards are irrigated, and you are creating artificial moisture, I mean, within your humidity within your field that enables fungus development. And we have a dedicated algorithm for 8 different fungi like mildew, downy mildew, and some other fungal diseases. We can differentiate between the infection risk level and the starting risk phase of the fungal diseases. So this is purely local humidity data-based disease risk alert mechanism. And besides this, we also provide variable rate application maps for managing diseases. These variable rate application maps is especially important for fertilizer application. On top of that, for Saudi, I mean, we also provide suitable spraying cars if the weather forecast, the wind speed is above some certain level of speed. We alert our farmers not to spray within those hours, because then you will have some stickiness problem. I mean, you will have problems in controlling the drift. So therefore, like, the AI also helps us over there. Lastly, I mean, we are, I mean, using 2 different technologies in red palm weevil early warning system. The first one is a digital trap with a camera. We built a liquid trap where the insects attracted via pheromone and falls into this trap, and via daily images we can count how many insects are trapped in our trap. But you know, the red palm weevil damages the trees because it puts its eggs within the palm tree, and when the eggs hatch and turn into larvae or worms, via acoustic resonance, we can identify whether the tree has some living organisms, I mean living red palm weevil worms or not. These sonic sensors are drilled into the individual red palm trees, and via the acoustic sounds of worms, we can identify whether the tree is invested or not, and we can identify them in very early stage, just like a few days after they hatch. So therefore, like, you can go and spray individual trees. So in a nutshell, that's how we leverage AI and provide early disease warnings for some specific areas. Thank you.
Wow, thank you, Tanzer. That was super concise and comprehensive. So really, really helpful to hear that information. I'm sure there's a lot of Saudi farmers that would benefit from that knowledge and your solutions, which you're already working on some projects there. So we'll come back to you for some questions later on, but I really want to thank you for that. Now, our next speaker is going to speak to us about some of the other aspects of this digital infrastructure and IoT. And it's my pleasure to introduce someone I've known for many years, Dr. Jan Vestra, who's strategic business developer at Priva, an organization that you probably are aware of, a leading controls company for CEA, as well as buildings around the world, and heavily involved in the Middle East as well. Jan is going to be speaking to us about smart farming, Internet of Things, crop production management, etc. Some of the technologies behind this. Jan, how are you doing? Are you there?
Yeah, I'm there. Yeah, you can see me. Hi. Just great. A question. My screen sharing goes right?
It's perfect. Yeah, it looks great. You're all set up.
Okay. This was the biggest hurdle for me in presenting, actually.
You got it. It looks great. So go ahead. It's your time.
Yeah, I'll start my timer because I always talk too much.
Yes.
Just in short. Well, I work for Priva. We are already over 65 years active in the greenhouse space. I just moved my monitor a little bit. And we do building management systems as well. As you might know, my colleague Fred is active in Saudi Arabia and in the region for vertical farming and everything around it. We do a lot of design ourselves of our technology and everything else. So that's us, and that's me. So I'm a mechanical engineer. I don't know a thing about plants. Only I always tell my colleagues in plant science, plants are just thermodynamic machinery. So how hard can it be? And that's usually that starts an interesting conversation, so to say. So on my role is entering the vertical farming space 2011. Met Henry 2012 already in Brooklyn in his first venture. And helping out universities in the world, mainly US, but also in other places like Japan, for setting up research and then bring them into connection with the Dutch greenhouse space. I live and work from the Netherlands, but I'm traveling somewhat, so to say. Talking about the greenhouse or horticulture, there's always some movement. And although there's a lot of greenhouse industry in the Netherlands, there's always a pushback, it seems, from the government and from NGOs. And we had issues with, methyl bromides, disinfection. People died because they were simply not taking care of the disinfection machinery when they disinfected the greenhouses. So they had to go to substrate growing. From there, we found out, or there was a new law, you cannot flush the water with all your fertilizer on the surface water, so you must recycle it. Then we had a different way that the gas prices were connected, just like electricity, based on use, based on peak hours. And then the semi-closed greenhouse came among us that could help optimize climate control, humidity, and everything around it. So on one end, it's technology development. On the other end is pushback from the Dutch government to start with, but it helped us design technology that fits in other regions as well, of course. So the goal, of course, is production, taste, quality, and it's always sort of a trade-off between taste and quantity. Well, for over 25 years, talking about AI. For over 25 years already, as when I joined Priva, before this, Priva already had weather forecast in the computer. So what's the weather going to be within the next 4 hours at that time? Do we need to switch on the artificial lighting? Yes, no. Power calculations on the demand or the requested demand of heat, or the foreseeable demand of heat from greenhouse. And put in these greenhouse characteristics as well as a feed forward with the grower behind the dashboard. I did a talk where you can see the blue dots for growers in Leamington, Ontario, where the weather is so different from where most of you are actually. But what we see, and Dr. Wang already mentioned that less people working in the greenhouse industry, and on the other end, operations must adapt to technology to become or to stay profitable actually. So it's either you go for the niche, very specialized crop, high value, high value, or you go for more bulk. But then you need a lot of technology to keep track of what's going on as a grower. You can see here all the pictures, full attention to the controller and the processes, close attention to market demands, but also multiple growers. Big greenhouse operations have different growers for different sections, for example. So you need some more technology. I will have Abdullah enter. Yeah. But what we saw in this whole shift towards more advanced technology is that we must not focus just on greenhouse climate. And my friend at the time, about 25 years ago, said, we do not control the greenhouse climate, we control the climate inside this measuring box. Theo Gilling, who did his work at a lot of research in Wageningen University at the time. And moving from there, in 2000, he came with this idea. Why don't we have combinations of plant science, mathematics, and computer science, and have a virtual plant that tells what to do in terms of irrigation, CO2, radiation, how can we adapt to the weather, and everything else. And gradually, we moved into that direction as a company, to say, but also the whole industry. I think this was a campaign we had 2002. I thought it was a little bit tacky. The plant wants to be fully informed. The plant likes to have money for other things, speaking plants, and so on and so forth. So a move went towards more model-based controls, where I call it empowering the grower. So it's not just plant empowerment, but also a big push in the right direction for grower empowerment. And this idea was envisioned a long time ago. Browsing the internet, and internet knows everything, I stumbled upon a whole series, but for sake of time, just one of these pictures. 1961, a good year in my mind, but factory farms. And what you can see, 1961, sensors, those automatic control devices for today's wonder machines, will adapt to the requirement of precision agriculture. As you can see on the upper right-hand side, genetic modification of tomatoes was not an issue at all. The bigger, the better, apparently. But even at that time, so that's 64 years ago already, was a thought about that. And then moving on from there, we had Uding Tekate. This is a picture of his PhD thesis, and Professor Hashimoto from Japan talking about the speaking plant. And I will skip this one, but I will read the lower one. It can be concluded that the replacement of the grower by the computer, which from an ethical point of view is regarded to be undesirable. How did it shift with autonomous driving? From a heuristic point of view is seen to be untractable. Both points of departure arrive at the same conclusion. The availability of computer system does not offer the researcher a shortcut from science to relevance. Well, and then we had AI among us that came for the rescue, so to say. And I think times are changing, and the times are changing rapidly. We had Bob Dylan singing it in the 60s. The times, they are changing. He had no clue what's coming over us at the moment, I think. And what we are aiming for now are different goals. So savings on energy, saving on the price of energy, and using multimodal controls like electricity, gas, waste heat, city heating, whatever. The saving on water, like the former speaker said, with satellite images, but also inside a greenhouse, optimization of labor, and can we choose quantity or quality? We have a customer who grows roses. We have several customers. Some customers have the same type of roses. One picks 8, the other cuts 12, but they make the same amount of money because of the difference, the huge difference in quality, actually. And then we run into some tensions, like a former professor at Leuven University said to me, we have plants that are individuals, that are complex, dynamic, and time variant. So what you mess up today, you find out 2 weeks later. Well, control systems must be accurate versus individual, must be compact, fast, dynamic, and time variant. And looking at controls, well, we see this is the normal way of controlling. We do a measurement, we have controller, the system changes. We measure again through a sensor system and see how that works. Basic control theory. And you need a lot of data already to make that simple part work. So there is talking about AI or Internet of Things. Usually we rely a lot of wired sensors simply for reliability. And that within a greenhouse, especially tomato greenhouses and so on, wireless is not always working so well. So we see all this whole range of measurements, temperature, humidity, electric conductivity of the water, which is a measure of the amount of fertilizer, pH, CO2, radiation, plant characteristics, and so on. And then we have another challenge because I had a data scientist joining us. He said, well, I'm for big data. And whoa. I said, well, the greenhouse industry is low on data because we have one measuring device per 4 hectares or so. So there are two routes. One is cheap sensors, a lot, smart dust, as Theo Gieling called it 25 years ago, and look for better models. And how can we go for the best of both worlds? And what we are advocating for is don't go simply for black box models. Put in a lot of data, make something out of it, bake a cake, and then hope for the best, because this can be dangerous in a lot of ways. And we think, for example, correlation is not equal to causation. Well, we see that, and we think you must, when you start automatic growing or autonomous growing or Internet of Things, AI, it must be a mix of data-driven and of mechanistic modeling, where the math simply blocks you in instead of that you can go AWOL, so to say. Well, smart irrigation is one where we have a control loop with the weather forecast, the radiation forecast, and the amount of irrigation that we give over a day. This is used outdoors in strawberry growing on gutters. And depending on the measurements of our growth, our growing scales, we use scales. We could decide, when do we need to start with irrigation? When can we stop with irrigation to make sure that the plant ends with dry feet at the end of the day? And by doing so and optimizing over the day, we can optimize as well how much water is needed for a plant. So feedback loops, water content, and this is an important part. It's just one spike. One thing often overseen, also we found out with students, is the sample size. This one spike, which you can say, well, it's an outlier, just 2 wrong measurements. It turned out that just before this, the amount of water given to the plants was just not enough. So the plant used all the water available to the roots, which meant that the next irrigation cycle, all the fertilizer that was left behind by the plant because it needed just the water came out again. And we could see by this spike, which you can say, well, it's an outlier. You can see, well, it's important to watch your irrigation and see how much did we wrong or how can we change in the parameters. Same goes for this. Then I read yesterday, it was also about airflow. Well, there's a lot of things to be said about airflow. So I contacted Lu Yang Kang. I contacted some other researchers at Wageningen University. They sent me some pictures. I looked into this from Kati Steppe from University of Ghent. Airflow in a greenhouse or a vertical farm is not just a gimmick. There are different ways of heat transfer. And, well, in short, running out of time, we look for the boundary layer, the small layer of air that's above and below a leaf, because that's the resistance for CO2 transport, resistance for heat, and resistance for moisture transport. And in all that ways, we can see, well, whatever happens, low wind speeds, everything opens up. High wind speeds, the boundary layer is broken, as you can see in the right side of the picture, which means that the stomata are closing, no CO2 anymore drying out of the leaf. And then we come to something that's more of an in-between knowledge and models and just a gut feeling. How can we control this in a better way? Well, one thing we want to talk about at the end is digital twins. How can you build a model of a greenhouse? We did already for building. How can you model and tune a greenhouse operation? So Bram van Toor, he is here in the room actually, came up with a thesis. Other people are writing thesis on this specific part. And with the digital twin, we have an in silico, we have a copy of a greenhouse with its crops inside a computer where we can mimic everything, can do simulations, but especially can do optimizations before we kill a lot of plants and see how we can use all this to use it in a better way. 44 seconds, Henry.
They're very, very much efficient on time, Jan. Jan has been at many events that I moderate, so he knows how strict I can get about timing, and he's learned. So excellent. Thank you so much for that presentation. We're going to go deeper into some questions on this, so stick around. Jan will pull you back up. But for our last, but not least speaker of this session, I'm excited to invite Rita Pinto de Abreu to the stage. Now, Rita is someone I've gotten to know over recent years. She leads global irrigation water team leader at Moliere Inc. And if you haven't heard of Moliere, I'm sure you're going to learn about it now, but it's an exciting technology for water efficiency and optimization, et cetera, that we'll learn about. And she's going to be speaking about advanced irrigation management for smart farming and water saving technologies. Rita, are you there?
Yeah, I'm here. Hi, guys. Hi, everyone.
How are you doing? Are you calling in from Portugal today?
Yeah, I'm in Portugal now. Yeah.
Okay, we're tracking all the countries. I think we're at maybe 7 or 10 countries at this point.
Yeah.
So guys, do you want to share your screen? Make sure.
Yeah, I will share my screen. Just give me a moment. No.
But it's definitely exciting to see this international collaboration, and so grateful for people dialing in from all around the world. For me, the sun is just about risen here in New York City. It was completely dark before, but now we've got the natural light. So that's waking me up. So while Rita's getting that ready to share her screen, I had the pleasure of actually visiting some of Moliere's facilities and projects, both in the Netherlands, with some of their work in deep water culture, controlled environment agriculture facilities, to manage cleaning of the ponds, as well as manage cleaning of those really big water systems in DWC systems. Yeah, it looks like it's loading up here, and there we go. So
sorry, because I don't know why it was at the end.
Okay, we'll get to the beginning.
So
no problem.
Now we are starting, okay? Okay, so once more, so my name is Rita Pinto de Abreu. I'm the, like Harry have present me, I'm the team leader for the water irrigation in Moliere. First of all, it's an honor to be with you all today. And I like a lot because we are gathered here to address one of the most pressing challenge that we are facing in the agriculture. And this will help us also, I think, all together we'll be able to, for sure, have a better future that's coming, okay? So for start, I want just to address a little bit what is the water crisis in agriculture, and just to give some numbers just for us. Sometimes it's a little bit scary, but I think it's good for all of us to hear, okay? So by 2050, we will need 7% more food for near 1 million people that we will have. Agriculture is, as you probably all know and have heard, already use most of our fresh water, and the majority of that fresh water is wasted. Okay, so right now, this is a fact, is that 2 million people live on areas that have a lot of concern related with water. They don't have enough water, and these facts just show us that we really need a solution. Okay. Everyone is seeing my screen? Because this takes sometimes a little...
I was a little delayed in the load, but it's
okay.
No worries. Okay,
great. So saying this is that we all of us are convinced that traditional irrigation is super under immense stress and immense pressure. And so, as you all know, probably it's that we lose more or less around between 30 to 50% of water by evapotranspiration, runoff, deep percolation. And this inefficient leads to an environment, operational and economic impact. And what did this mean in fact? Like overwatering in some areas and underwatering in other areas, fertilizing, washing away before the plants can uptake all the nutrients that they need. Billions of lost annually in inputs, they are wasted. A lot of soil compactation, poor aeration, and fertilizer runoff pollute also the waterways. And this consequent also to a reduction in crop yields we estimate around 20 to 40%, and an increase of pests and diseases. That it's what we are facing when we are talking about traditional irrigation. So this is basically when water management fails, everything will suffer. And this is what you're seeing on the screen, this timeline basically is what we are, what's going to happen when we have a bad water management. So at the end, the crop will suffer. So, and poor irrigation will lead to bad soil, fewer nutrients, and of course, weaker plants. And consequently, lower yields, high costs, more pests and diseases, and this will hurt not only the environment, but also the farmers. So this leads basically for what we can do and what we will be starting to use in the future. So precision water management and tools. Okay, the solution lies on this, smart farming. And so the key principle for that is basically deliver the right amount of water at the right time with the right quality using the right technology integration. Our goal is super clear, and for us is maximize crop production while minimize water inputs and environment impact. I would like to challenge a little bit and basically talk about what could be the quality of the water that is really a game changer, okay? So I'm going to start to talk about something that probably some of you already heard, others not so much, but I will believe that at the end of this presentation you will understand a little bit better. So dissolved oxygen is essential for root respiration and nutrients uptake. Clear water means that we will have more healthier plants, so with less resources, and so at the end we'll have all this water quality will impact significant on the nutrient availability and the support of a better soil biology. We can have all the water in the world, but if we have a poor quality water, the crops at the end will suffer. So let me introduce what Henry already talked about, is that the nanobubble technology. So the nanobubble technology is a major discovery in the irrigation water management. Nanobubble and dissolved oxygen are introduced into the irrigation systems with the key objective, basically is enhancing and improving completely the water quality. Nanobubbles are 2,500 times smaller than a grain of salt and persist in water for over much more time, normally around 6 hours, than the rest of the bubbles that exist. And so this means that we are able to deliver a lasting oxygenation to the water. Okay, just for you to understand a little bit, because I think sometimes talking about nanobubbles is difficult for people to understand. So you can see this. So we have on the left side of the screen, you have nanobubbles. You are not seeing nanobubbles because they are super small, so you are not able to see it. And then you have a champagne bubble that it's smaller than a nanobubble. And then you have soda. A soda bubble, it's a little bit bigger than a champagne, but is much bigger than a nanobubble. Just for you to understand is that tiny bubbles stay in water longer and deliver oxygen in a more efficient way. And as you can imagine, this will impact directly on the plant, on the soil, and on the capability of the plant to be more resistant to some diseases and some pathogens. So we have three key things that I would like to mention now to you. So nanobubbles alter the surface tension and contact angles of the water, improving how it reacts and how it interacts with the soil and other surfaces. And this enhances water penetration in the soil, supports effectively the cleaning of biofilm, and optimize wetting process in the irrigation system. We have some experience, and then you can see, I'm just sharing with you some of our comments and remarkable results from some customers. And then we were able to up to 30% improve on crop calibers, up to 13% reduce in use, and we were able to lower labor and consumables inputs. Then another thing that I think is super important to talk about is control biofilm and prevent diseases. Nanobubble helps maintain the irrigation systems cleaners. Why? Because they reduce they have an effect of scratching the tube, and so cleans your tube. And sorry, I'm losing. And so basically, I think they could be a huge impact and a valuable tool for the modern and sustainable agriculture. And so you have some examples over there from some input from the customers that were able to reduce by 50% the use of cleaning chemicals, and also reduce up to 89% the clogging on the emitters. Then another thing, another thing that we are able also to improve is improve capillarity, action, and infiltration. What this means, basically it means that we are able to maintain the water more close where they need it. So more close to the system, the root system, and more easy for the plant to uptake that water. And consequently, we'll improving the water penetration and distribution of that water. Okay, so this, we have several customers that have told us that we are able to reduce around up to 20% of reduced soil compactation, and this consequently will lead to a water saving around 30%. Sorry, this is some examples from some research that we have, not only research, but also from some success grower stories. And so as you can see, I have shared three completely different locations, different crops also, and different type of installations. So you can see on the first, in the Netherlands, the strawberry grower in glass houses saw 75% of lower P2 count and healthier root system mass. In tomato, in glass house irrigation reservoirs require 50% less of hydrox peroxide for sanitation and biofilm removal. In Chile, we have seen cherries growing in native soil, and they were able to achieve 43% of water saving, and of course improving the uniformity of the irrigation. And in Sicily, the table grapes that we were able to help the grow have significantly improved on water infiltration and reduce of salinity also. So this is just some examples that if you need more, then we can reach out and I can give you more information. Sorry. Then I would like just to talk about a little bit where we are heading right now, and through climate resilience, and also we have to talk about IA and EOT integration, of course, for real-time monitorization, data-driven decisions, and circular system for zero wastewater management is where we are at. As you can all understand, that early adopters for smart irrigation technologies will lead the agriculture in the future and will be the ones that will gain a more competitive advantages in the future, of course. By 2030, all those technologies that will be around this could save enough water to supply around 100 million people around the world, while increasing also global food production by 30%. This is our goal as Molière, of course, and I think everyone in this room it's have the same goal. So at the end, I just want to say thank you for all. And just to leave a few messages is that the future of agriculture depends on our ability to innovate, adopt advanced water management solutions. Nanobubbles is just one of a lot of existing one. It's just an example that how we can and we should transform challenge into opportunities. And I think let's work together for build a sustainable and more resilient and a more productive agri-food system for all the generations that are coming. And I just want to leave you with the last message is that this is just a glimpse of what nanobubble can achieve. We are just a tiny bubble, to be honest. So imagine the possibilities that we can do if we continue to innovate and transforming the future of the entire market that exists. Thank you a lot, and I'm here for all the questions that you need.
Thank you so much, Rita. Really appreciate that. Yes, and
you're welcome.
All great things start small or maybe nano, but it's been very exciting to see Molière really develop over the recent years. And I got to attend your event in LA and learn about all the applications, which you only just gave us a small preview of.
Yeah.
So we're going to have a Q&A period. If any of our attendees have questions, you're welcome to use the chat, but I have some of my own questions for these speakers. First of all, I want to go to Dr. Hao Wang. If we can pull Dr. Hao up, and Dr. Hao, if you recall, he was speaking about robotics in the farm and in the greenhouses as well. If we could get Dr. Hao up and his mic on, that would be super. There we go.
Yes, Harry. Yeah.
So, I mean, look, the robotics question is so exciting. We have labor challenges around the world in agriculture. I think in the context of the Kingdom of Saudi Arabia, it's interesting because, you know, labor costs may be lower, but we know that might not be forever. And so automation, I think, is very, very interesting. But I guess I wanted to ask the question, you know, there's always this issue of farmer adoption, right, of the technology and how farmers need to see something work or what the process is. Could you talk to us about farmer adoption of robotics and some of the obstacles and how you've seen those overcome?
Okay, thank you for the question. This question, it's a very deep question. For the robotics, it's high tech and it's very useful to reduce the labor force because you know the aging problem and labor shortage. So this problem is all over the world, not only in China, in Asia, or it's all over the world. So we are facing the problem in labor shortage, especially in agriculture. So the first thing we want to develop the robot to make the agriculture cool. So the young people want to do the cool things. So the first thing, the robot can make it cool. So I hope that it can attract some young people come back to the countryside. So when we adopt the robots, the high tech to agriculture, the first obstacle is how to make the farmer to use it. So because the farmer, they want to follow their own rules. They believe their own beliefs. So the first obstacle when adopt a new technique is about how to persuade them to use this, to try. So it actually, honestly speaking, it takes time and take a long step to persuade them. And the second I want to mention is I want to abstract the young people come back to the countryside, come to the farming work. So it's very difficult. We need to cooperate, not only the agriculture engineer, we also need to cooperate with the government, with politics, to show some cool things to new environment in the countryside, to modify the country, and then the young people want to come back and to use the high tech. I think only the young people can learn the high tech more. I think it's more quickly than the elder person, the aging people. I think, yeah.
Yeah, I think thank you for sharing that. You know, I think the point on youth is something that was brought up by Christine. And, you know, we know from the data that Saudi Arabia in particular has a very large youth population, and there's a push to engage in agriculture. And you're right, the opportunities in that need to be, as you said, cool and attractive for them. And certainly robotics that can help them do more with less and have the more technological systems could be appealing. But sounds like there's a lot to unpack there and to investigate in the kingdom itself and how youth can engage in that. But I think it's a really exciting frontier. I really enjoyed the technology you showed about the field mapping, where it's first, designing how the robot itself is going to move across the field optimally. Sounds like there's so many underlying technologies besides the robots we see that were interesting there. Now, Tanzer, if I could pull you up, I wanted to ask you a related question, but more from the perspective of your work at Doktar. If we could have Tanzer, if he's still here. Let's see. There he is. Just takes a moment for the audio to be turned on. There you go. So
yes,
thank you. I really enjoyed your presentation. And I think I want to ask a similar question for some of these digital tools, right? I mean, I guess you have the combination on your end where they have to adopt certain irrigation technologies, and then they have a digital tool that matches it, if I understood correctly. So, what are the adoption challenges you're facing in this region, and how are you overcoming them for farmers to adopt these technologies to use less water and to leverage AI and digital tools to do so? Is there a lot of education needed? Is there delays? Is there hesitation, or is it just embraced and easily implemented?
Well, as I said, we have been in Saudi for 2 years, and we mostly work with very progressive farmers, and we are collaborating with costs in that sense. So therefore, we haven't faced any progressiveness issue or adoption problems because we are on the rollout phase. But the thing is, we had some coverage issues, but that was maybe 15% of the locations that we were willing to deploy sensors. But in the long run, right now we can correctly measure the soil moisture and the trends, and we can link them with the plant variety, the orchard variety, plus the weather data. And we distill a recommendation. The recommendation is irrigate every other day for 45 to 50 minutes, for example, okay? We are willing to move one more step. That is the automation step, which will probably require $10,000 to $11,000 per hectare additional investments. But for example, if you have already these professional irrigation systems, I am just talking about the date orchards, by the way. The bubble irrigation system, you put 2 individual bubbles per irrigation tree, but you bring the water with pipes. If you have that system, on top of that, you just need to spend maybe $4,000 to $4,500 per hectare, all right, to make it automate the system. So what does it mean? We can integrate it with sensor signals, and it can take care of the automation. That's our goal, to be able to get here within the next 2 years. But that may require additional investment. Right now, I know there is more than 140,000 hectares of date orchards in Saudi, and probably majority of them have not professional irrigation systems. I have seen some farms with manual irrigation with labor force. But most of the farms have these, more or less, probably 30-40% have the park systems, but they need to be opened by manual labor. So you do not have the exact timing of irrigation control. In order to efficiently irrigate, we will provide the data. The next step will be the automation, and for automation, there will be a investment requirement. As I said, that may be a challenge in the future.
It's just such a massive, massive challenge, the water use and all the date plantations there. So it's exciting you're tackling. And it sounds like there's incremental levels where first there's, can we manage irrigation effectively before we move into an automated system? And I think that's an interesting answer that you sort of have to go step by step into it. And I think there has to be exciting incentives for the farmers to adopt and to learn these solutions. Jan, I want to go over to you really quickly. It looks like your mic is off, which is great. So, you mentioned briefly digital twins in this whole talk, and I think digital twins is such an exciting, interesting topic. And I was just hoping, since you're quite a visionary, right? You travel the world, you do business development work. What is the potential for digital twins to make a difference in our food system, and maybe contextualize it in the case of Saudi Arabia?
Yeah. Well, to start with the digital twin, we started with a building simply for optimizing the thermal behavior of the building to the weather and everything else. But I think from that, it's starting to how to have a model, to have a working model, a fast working model of a greenhouse with a crop inside. Then we can sort of predict for the next 5 minutes or the next 10 minutes. We know what the weather will be. In Saudi Arabia, that's less challenging than we have here in the Netherlands, I guess. But the weather forecast, radiation, temperature, everything else. And based on that, then we can run sort of a quick model of that specific greenhouse for what will it mean for the next 5 minutes, or next 10 minutes, how much water do we need and everything else. And then we can optimize in semi-real time the amount of water that we give to a plant. It's easy. Well, Rita already said as well, overwatering is an easy thing. And especially in the Middle East, you switch on the pump to make sure that there's enough water. By optimizing, you can easily save 40% of your irrigation, I think. So the digital twin gives you tools for monitoring. It gives you tools for what are the outliers, what's going wrong compared to what my model says. And you have a sort of cloud-based optimization that can be so much more complex than what you can fit or press inside a controls computer, for example. So that's the short version. And
we appreciate the short version. To be totally honest, that's great. But it sounds like you can model like infinite scenarios to be more accurate in the interventions you make. And I suppose there's a future we could imagine where AI can work in the background to sort of be in real time. I think even Priva 1 maybe does this on the energy side, but in real time, you can sort of imagine those scenarios while you're operating a facility to then make the right decisions. Is that sort of the next step, the future of this?
Yeah. Of course, now what we do, we run it. We start with buildings. We do some greenhouses for energy, but we run the model in the cloud. And then we set new set points towards the computer for the next 5 minutes indeed. And that's quite a challenge already for such a complex system to run an optimization and find out which parameters do we need. But I think in digital twins, and there's a lot of talk about it. We had a discussion with Maastricht University. They said, well, there are different aims. We aim at optimizing the greenhouse operation in terms of, does the grower want quality over quantity? Like I said, with the roses, you can go for high sugar or for a lot of tomatoes, but not both. And what settings do you need to achieve that?
Right. So that's the objective. Okay, so let's go to you, Rita, really quickly. We've got a question from the audience. I want to give them a chance. It's in the context of organic farming in Saudi Arabia. To what extent can nanobubble technology enhance soil health and water use efficiency? So I think we're really looking for something specific. What does your gut tell you, or what do you know about the Saudi context related to nanobubbles that could be a benefit?
I think basically, let's say, it's important to say something that I've forgotten to mention, because for me it's supernatural, but nanobubble technology, it's a green technology. So we don't use chemicals. Everything is supernatural. So organic farming fits exactly where we are. So it's a really good joint venture. So in the Saudi region, what I'm seeing is that there is a lot of problem basically with salinity. So we are in fact be able to reduce potential the salinity of the soil, and so that's, I think, will consequently improve the health plant and also the soil quality, and of course the use of in a more efficient way the water. in terms, let's say, Molière has a range of products that we can go from a small farmer to a big areas, big open field areas, not only exclusive on greenhouses. We start in greenhouses, it's true, but right now we are able to manage a lot of areas. And I think in Saudi is what we are seeing. In fact, we just sold our first system in Saudi. 2 weeks ago, 2 weeks ago. So it's a good opportunity to have a real time opportunity. And I'm sure that in the future, if I can then connect with the person, we can do some visits together and you can see it in real life. I just want to add something that you asked to our first presenter is related with adaptation of new technology. Is always a challenge, but is something I think we are moving more for the young generation are looking for different things. So I think all of us that we have talked about here, we are talking about the innovative technologies, but they are new. Of course, will take time, but I think right now we are on a phase that everyone is looking for novelties. That's something that, and I'm talking about irrigation systems that you know that I have a huge background on irrigation. And so it's something that I think everyone is anxious, and even the farmers. And so I think will take time, of course, but we have a huge opportunity in front of us, a huge opportunity, to be honest.
Yeah, we have a lot of work to do. Well, I want to send a special thank you to our 4 speakers in session 3. Thank you so much to all of you for what you shared in your Q&A. And without any delay, we're going to move into our final session, session 4, where we focus on policy, economics, some business models related to this. And to kick us off, we have Mr. Danny Mohammed Al-Husami, COO at Morek Specialized Agriculture Company in Saudi Arabia. He's going to be speaking to us about business models for tech-enhanced farming in drylands and a case study specifically from Saudi Arabia. Danny has a wide range of experience, which he can tell us about, including vertical farming, managing teams, working on the food security strategy, etc. Danny, are you there? Let's get your audio on.
Yes, I'm here. Can you hear me, Henry?
Yeah, thank you. Loud and clear. Welcome. Well, the stage is yours. You have up to 15 minutes. We're a little bit over time, but please share with us this case study.
Sure. And the sun is setting here, by the way, so in Riyadh.
We're switching.
Absolutely. So I would like to share my screen to begin with. Yes. Oops.
Yeah, sometimes it takes a moment, but...
Yeah, can you... Sorry. Can you see it now?
Actually not. Let's see if
let's try.
There we go.
How about now?
Yep, we see it now.
Okay. So let me just do this. Okay. So my name is Danny Al-Husami. I'm the Chief Operating Officer at Morek Specialized Agriculture. Morek is the leading Saudi agri-tech hydroponic farm here based in Riyadh. We're focused on high-density controlled environment food production. Our Riyadh facility operates a joint venture between Morek and Yes Health Group. That's just a little bit about us. Okay, so why farming in the drylands? Excuse me. Saudi Arabia, as you all know, is one of the toughest agricultural environments in the world. We face extreme temperatures, limited arable lands, and one of the lowest water availability globally. This has created decades of dependency on imported fresh produce, which means long supply chains, high costs, and exposure to global disruptions. Controlled environment agriculture and vertical farming are becoming essential tools for the national food security. They allow us to grow high quality produce in a stable and predictable way, independent of climate, season, or geography or whatsoever. So it's not about replacing traditional farming. It's about complementing it with systems designed specifically for the dryland conditions. Okay, I'm going to move to the next slide. So what is the challenge? The core challenge is the instability of the current supply model. When we rely heavily on imports, we inherit global volatility, whether it's fuel price changes, logistical bottlenecks, or international market fluctuations. Freshness is also affected by the time the produce travels thousands of kilometers. Quality degrades, and the shelf life obviously gets shorter as well. Logistic costs in the regions are high because fresh produce require cooling, fast movement, and careful handling together. This leads to avoidable post-harvest losses. So to ensure stable and resilient availability of the fresh produce, we need production systems that are local, that are local, resource efficient, and economically viable in Saudi conditions. Okay, so Morg's vertical farming model. Our farm here in Riyadh is built to address these challenges directly. The facility is designed as one of the largest vertical farms in the region, using high-density, multi-layered hydroponic systems. So we have 16 racks across and 19 high. Climate control, lighting, airflow, and the nutrients delivery systems are engineered for precision and consistency across every production cycle. The system is designed based on technical partnership with groups that have decades of commercial experience. We adapted this knowledge to Saudi conditions, high heat, in Riyadh's case, extreme dry weather, the opposite of Jeddah, obviously, and local market requirements. Our model funnels produce directly into major national retailers, and including the largest national retailer in Saudi Arabia, creating a short and reliable supply route, pretty much. Okay, so our business model overview. We focus on stability and efficiency. We start with leafy greens and herbs because they offer pretty much fast crop cycles, strong demand, and predictable outcomes. We operate continuous seeding, which means we plan production we're not tied to a season, but by daily outputs. We decide what to grow, when to grow, kind of thing. So this gives us ready, reliable harvest volumes. So commercially, we use a B2B structure anchored by long-term retailer partnership. These aren't speculative sales. They're pretty much structured agreements with the high-volume national retailers that allow both sides to plan ahead and avoid any surprises. So this alignment is the foundation for a scalable and economically sustainable vertical farming operation. So, okay, economically, vertical farming has a distinct cost structure. The CAPEX side is driven by HVAC, LED, lighting, racking system, and so on. These are long-term assets that define the farm's performance. OPEX, on the other hand, is influenced primarily by the electricity, labor, packaging, and whatnot. Energy is the dominant factor when it comes to that. So the strength appears in efficiency. Our system reduces water use by 90% compared to traditional farming, and pesticide use is zero, so we don't spray any pesticides on the plant at any stage. This shifts the model from input-heavy to technology-driven, producing clean and consistent food with minimal resource waste. So, okay. The ROI in vertical farming comes from operational predictability. First, vertical stacking increases yield per square meter significantly compared to an open field system. Also, fast crop cycles enable multiple harvests per year, which creates consistent cash flow. Third, being in the center here, located near retail DCs, sharply reduces our transport time, shrink, and waste. That's why we chose Riyadh as an example versus Jeddah, because we're right in the middle, that we can supply the eastern province and to Jeddah and whatnot. And finally, long-term agreements with major retailer give us stable pricing and predictable revenue. Together, all these factors build a scalable model where return on investment comes from efficiency and reliability rather than charging the premium cost. Okay. So several policy enablers can accelerate the success and ROI of modern farming systems in the kingdom. For example, targeted energy incentive for high efficiency indoor farms would directly address the largest operating costs. A fast-track regulatory pathway for controlled environment agriculture would reduce approval times and lower entry barriers. And local R&D support, including, as an example, lighting optimization, nutrient formulation, and crop performance research tailored and controlled environments, builds Saudi-based expertise. Integrating vertical farming into the national food security strategy strengthens long-term sustainability for investors and operators. So these measures create an environment needed for sustainable private sector growth in the agri-tech sector. So over the course of the developing and operating this project, several lessons emerged. I would say one of the most important one is securing commercial commitments before scaling is essential. Production must be aligned with the confirmed demand. That way you avoid any surprises on whatsoever. And localizing inputs, especially, for example, raw materials such as packaging, it reduces the cost and shortens lead times. And finally, investing in training, obviously this is the non-negotiable one, controlled environment agriculture requires operators who understand both the technology and the agriculture itself. So building this talent locally is a key for long-term priority. Okay. So what are the challenges? Despite the promise, the model comes definitely with some challenges. Energy is the highest operating expense, making efficiency optimization is essential. The sector also needs more specialized skills, which requires consistent workflow development and training. The supply chain for certain inputs is still developing, although it is improving with the demand. And public awareness remains limited. Consumers understand organic, everybody knows it, but when it comes to vertical farming, still requires more education around the benefit of it, such as the pesticide-free production and the freshness of the product. And also growing it in climates like Saudi, where there's no water, super hot, and all these factors in. So addressing these challenges strengthen both the economic and operational performance of indoor agriculture in the kingdom. Okay, so looking ahead, our strategy expands beyond leafy greens into additional high value crops that aligns with the technical and economics constraints of vertical farm systems in the drylands. We are developing value-added products, including mixes and ready-to-eat formats tailored for local consumers' preferences. We are also exploring ways to upcycle organic byproduct uses, contributing to a more circular model. Ultimately, the goal is for Saudi Arabia to become a world leader in modern agri-tech, exporting knowledge, capability, and innovative production systems across the wider region. And that's all that I have for you today.
Excellent, Danny. Right on time. Thank you so much. It's
my pleasure.
Cool. I've definitely heard about your company before, but it's nice to hear your talk. And
thank you.
As a big vertical farming consultant and fan, it's exciting to hear what you've done. I hope to visit your project someday next time I'm in Riyadh as well.
You're more than welcome. Anytime.
Thank you so much. So moving on to our final speaker before we get into a short Q&A with both of our last two speakers. It's my pleasure to introduce Mr. Derek Smith, who's the Executive Director at the Resource Innovation Institute, RII, in the United States. He's also joining me from the USA here today. And this is a really interesting topic because, as Derek will tell you, RII is involved in bringing collaboration across the sector and benchmarking of data. And these are key things he's going to be talking about, collaborative research networks, and how could they be potentially something that Saudi Arabia could learn from. So Derek, how are you doing? Good morning.
Good morning. Yeah, good afternoon, everybody.
So thanks for joining us. You are hopping on to, we've had 11 speakers, I think, before you. So welcome to
the cleanup, huh?
Yeah. So we're asking you to give us a last strong bit of knowledge and excitement here. So tell us a bit about yourself and share your screen. Let's make sure that works first of all.
Yeah. Well, it's a pleasure to be with you all. Thank you for the opportunity, Henry. And my organization is actually similar to Estidama, it seems. So it's a pleasure to learn more about you and to look at your great work. Is that working?
Yeah, it's just loading up now. Perfect. It's ready.
Okay, great. So as Henry said, my name is Derek Smith. My organization is Resource Innovation Institute. We've been around for about a decade. We work with federal agencies and states to figure out how to scale CEA in the US, in particular with a focus on resource efficiency. For the past 2 years, we've been working with the Department of Energy on a CEA accelerator, and that is in partnership with Lawrence Berkeley National Laboratory, one of the premier energy labs in the US. And what we have come to is that really for CEA to scale, we're going to need public-private solutions. And so the work that Estidama is doing, the work that we're doing is really critical, because how do we collaborate as sectors? How do we do the research that really gets us to scale? The US is a very large place, very different than other places in the world where CEA has scaled or has found a route to take hold. So it's going to be a different model, but we do know that it's going to be public-private. And I'm really excited to share our latest conclusion on where we think things should go, at least right now, what we're facing in the US with data center expansion. And I know you all are facing this as well. I understand there's concentrations of data centers near Riyadh and Dammam, probably elsewhere as well, taking a lot of energy, maybe having some water impact, certainly with the old design of data centers, but now they're a lot more water efficient. But the question is for us, we have this energy using sector that is expanding rapidly all over the world, and it's going to continue, obviously. It's kicking out so much waste heat. And meanwhile, the CEA operations need energy, and it needs to be a sustainable supply of energy at a low cost. And so is there something we can do to co-locate these sectors and really help things scale? And we've seen that this has been attempted elsewhere in the world. There's good progress in some places, but this has not really been done in a meaningful way where everything is truly connected, and in particular in a version of what we're calling farm parks, which is not just data centers and CEA, but also a whole ecosystem of other organizations around this business park campus. So that's what I'm excited to share with you today. I'm going to advance the slide now. The first thing I want to say is that co-locating data centers and high-tech greenhouses is both feasible and strategic. We did a report that we recently released with the state of Virginia, which is the #1 data center jurisdiction in the world. 74% of the internet traffic runs through Northern Virginia. And they've run out of land in that part of the state, and they're looking at moving the data center expansion into the southern part of the state, which is where the agricultural legacy is. And so it's rural communities. They want jobs. They want a farming legacy. And so we're exploring how could they move data centers down there and co-locate with greenhouses. And so these are all the reasons that this makes sense. But in particular, it's the economics and the economics for both entities that could work. So what are farm parks? I'll give you a more complete description here, but these are regional resilience hubs with integrated food, energy, data infrastructure. And I'll explain the integration. And the way we unpack the way this can happen is very strategic because it works for all the sectors. Importantly, the data centers they're on a very tight timeline to get built. And so there is strategy here where they can get built, they can operate standalone. There's no timeline impact. Essentially what they need to do is just have pipes coming out that are stubbed off that are ready to connect ultimately to greenhouses later, right? So that's number one. Data centers come in and we leverage their location. The next thing is the central resource hub. This is the most important part of the farm park. This is the interconnection between the data center and the greenhouses and the other businesses that are located in this farm park. This is where the waste heat gets connected from the data center to the greenhouse. CO2 also off the energy system, the CHP system, and then the water loops. So you can imagine that this is running all these resources throughout the business park among the tenants in a way that's making sure that every tenant gets what they need when they need it. And also it's important because this decouples the data center from the greenhouse operations for operational security. So the way this central resource hub is financed, insured, governed, owned is really critical. And that's the key thing that we're exploring. How do we get the economics right? What is the role of the public sector in investing in this central infrastructure that can advance all these objectives that the public sector wants and the private sector wants? Then we bring in the greenhouses. And I just heard Danny's talk about the importance of the offtake agreements. We build in long-term offtake agreements. We co-locate distribution centers. We co-locate retailers possibly nearby that want all the product. And so this is local production in local communities. Cold chain logistics, as I just began to say, we can spread out the waste heat that is going to be variable throughout the year, right? So the greenhouses aren't always going to need it, certainly not in the summer, right? I understand Saudi Arabia gets relatively cold in the winter, so it could work then, but obviously in the summer, you don't need the waste heat. And so where else can that waste heat go? That's the purpose of having a business park that has these different businesses where you can match the resources to the needs. Again, what does each tenant need, when do they need it, and how that is governed. And the fifth thing really could be any other target sector that a local economic development agency wants to bring in. We're listing just some here, but obviously you could locate robotics companies that want to serve all the greenhouses. There's a concentration of customers right there. So that might be a great strategy to bring them in. But any other supplier, any other research, any other opportunity to have economic interests meet energy interests could co-locate. So these are the outcomes. These are very rough numbers because this will vary quite a bit depending on location and whatnot. But this is a lot of economic development, $5 billion US, 1,000 jobs versus if a data center comes into a community alone, it's probably 40 to 100 jobs. And it's just not enough for these communities. So with this strategy, the local community, the public sector can say, we're doing something different here. We're bringing farming back. We're bringing 1,000 jobs. Yes, there's a data center there, but it's a purpose because the waste heat is being used throughout the park. And 2,000 mouths, depending on the crop, depending on what's actually grown, can be fed here. And also another important point is crop diversity. Each crop is going to use waste heat at a different level. And so that's another matching opportunity and an opportunity to expand crop offerings through this strategy. So this all makes sense to us because the data centers bring a lot of taxes to these communities, but the greenhouses really bring the jobs and all these other benefits. So we believe that this broader vision will help communities accept this kind of development more. and there's no impact on the pace of the data center development. So we're seeing a lot of interest from the data center community that they want to go as fast as they can go. They want opportunities to sell waste heat for revenue. They want CapEx reductions in the amount of chiller equipment that they need to install. And so there's a lot of economic opportunity that we can bring to bear here. But it's obviously a complicated co-location matchmaking thing that needs to happen. All of this is we came to this conclusion after this 2 years of work with the Department of Energy and Berkeley Lab on this CEA accelerator, where we developed a site feasibility tool. So this is a geospatial tool that is overlaying all kinds of data from soil, elevation, energy availability, utility, incentive availability, water availability, and co-location potential. So we've got data center operations on a map that you can overlay with all these other data sets. So this is already beginning to help the CEA sector in the US. Builders and others are beginning to rely on this tool. We've also developed a technology catalog, which it could be applicable anywhere in the world. And if Estidama or others are interested, please let us know. This is an exhaustive overview of all the technologies used in CEA with substantiation for the energy and water savings, and some cost information, et cetera. And so the point here is that we can work with states to have effective building and energy codes that align with these technologies, and then we can align the utility incentives to these technologies. But that's a lot of work. And then we've written a bunch of best practice resources. These are all free. They're on our website, on our resources page. These are the topics. But again, we've written a greenhouse co-location best practice guide. We've studied the high-tech strategies in other countries and brought that knowledge transfer to the US so that we can become a more high-tech center of CEA production. And then we've got a whole workforce development strategy, and we will be making an announcement soon of a partnership with Ohio State University to bring the certificate program for the design and construction sector that's building out the CEA operations. So how does this all come together? It's in a phased phased series over time. This is what it looks like. And all of these services, essentially down at the bottom, are the things that RII will support to bring this together. This does not happen without public-private coordination. And we're working also in the state of North Dakota, which is a very, very cold state. And so the data centers are coming there. They've got plenty of energy. They've got a very active public sector. And what we're doing there is we've got an advisory council that's forming that's looking at the waste heat. We've got a site-specific data center that has essentially 400 acres of adjacent land, and they are putting money into this project to see what the possibilities could be. So this is an analysis. It could turn into a development. And then later next year, we'll be working with Virginia to take the next step to actually try to host the first or locate the first farm park in the US. So we're excited about this direction. We think this is an example of a co-location direction that CEA should take advantage of to really scale and to find the right resource and economics that really make this work. So I appreciate the attention. I'm super happy to join the dialogue, and thank you again for the opportunity.
Thank you so much, Derek. I think for those of us who have been in the industry for a long time, myself since 2011, there's such a need for standards in this industry. There's such a need for these collaborative networks and research. And we talked about it for so many years in so many different ways. And it's really great to see RI really stepping into that and providing, like you said, everything from guidance on which sites to choose to the role of different equipment, energy efficiency, and how CEA could solve this problem related to data centers, which we're working on. So thank you so much for that. Very, very interesting. a lot to also learn from, as you mentioned, for Saudi Arabia and Estidama. Although some differences, again, I think you mentioned it, but there's not much need for heat in Saudi Arabia, but reusing water, for example, wastewater, there's other things that could be related to co-location or integrating these into cities in the built environment in a meaningful way. These are all things that would benefit from standards and pilots and case studies. So thank you so much. I'm going to have a question for you, Danny, in a little bit, but Derek in a minute. But Danny, I want to pull you up first to talk a bit about vertical farming, which I think so many Saudis are interested in, and people are interested across the world. And you mentioned some of the things that are necessary, right, to catalyze this and make this go faster. But what are some things you would do differently if you were to start over and do your first vertical farm again? What are some of the mistakes you can share with us?
So definitely the planning. Our facility took a little longer than expected. So the planning part of it, we did do the planning, we did do everything and do the due diligence, but the planning, we could have spent more time planning and more time planting.
Now you know where to reach me again. So for the next one.
Sorry, say again?
You know where to reach me next time for the planning. I'm a vertical farming consultant, but proper planning I think is a really good one, because you have to run a lot of scenarios, you have to expect the unexpected, and if you speed up too much, you miss that. Not to speak for you, but is that sort of what happened? And also on construction, this is one of the key challenges in the region, right? Did you face challenges with that?
Yes, construction was a little it didn't go as fast as planned, but it went very well. Let's put it this way. So the outcome was great, but the speed was a little on the, I wouldn't call it slow, but we had challenges. That's
normal, being a pioneer and doing something that's early on. So, and I want to talk about the retail partners. You have some retail partners which can be challenging. I mean, what are you hearing from them as far as what they want to see more of and how they feel about vertical farming? Any challenges or opportunities there you can share with us?
For example, our initial phase one, if you will, launch. We don't want to launch the whole product line. We want to keep it into a specific number of SKUs. They're asking for more, but we're saying we want to start with less. So we're getting pressure, obviously, this way, but it's not the end of the world. But scaling up one step at a time. And our output is going to be huge in this farm here. It's 5,000 square meters, and the output is going to be huge. So about 2.2 tons of leafy greens per day.
Yeah, that's a pretty big vertical farm. So wishing you the best with that. Of course, that's your scaled up one that you're talking about, right?
Sorry, say again?
That's your next one that is under construction, or sorry, I didn't know if you were planning.
I am in the farm right now.
We finished one. You're there. Okay.
We finished the construction and we're launching very soon, within a month or so.
Wow, really, really exciting. So Derek, I want to go over to you a little bit. So, RII is a sort of unique organization. I think I want to hear more about what a collaborative research network means, right? And what's the role of industry versus researchers versus you and government? How do these players work together? And what are some of the best practices that we could pull away from the structure of RII and how these groups collaborate with each other?
Yep. When we started 10 years ago, there vertical farming, greenhouse farming, high-tech strategies. A lot of this was informed by the cannabis market that was blowing up in the U.S., but the eye was always on the food production market and how to support that. But there was no guidance at all about how to do this efficiently and effectively. There was obviously research projects going on in universities on different crops and in the U.S. government. There's not really a clearinghouse for this information, not really a way for multidisciplinary groups to connect and share knowledge and bring consensus to different types of information. So we assembled a technical advisory council, which has, equipment manufacturers, producers, researchers from universities, utilities, governments, various agencies and governments. And that group can be assembled among those actors based on the topic, right? So if we're going to get into development, and we're going to get into permitting and building codes and all those issues, we make sure to bring that part of the government into that conversation. So for every piece of knowledge that we brought to the market, it's really not our knowledge. We're just the facilitator, we're the convener of bringing all these groups together, and we facilitate the dialogue. We make it a safe environment for everybody to share. Nobody needs to share their top trade secret. They can decide where the borders on what they want to share. But what everybody finds is when they get in these working groups on, say, AI and robotics, very, guarded subject, they let loose a little bit because they see that the objective is to support the market, to make the right decisions about how to integrate AI and robotics in the most effective and resource efficient way. And everybody tends to like it. They actually have fun. We create a really unique environment in these working groups. And then we write the document. We have a review process within the working group, and then also have a external peer review process. And we co-author generally always, with a researcher. And generally we choose a younger researcher who can advance in their career and is super motivated. But we always have a connection to a senior researcher as well in the project. So that's some of the ways that we do it, and happy to share more.
Thank you so much, Derek. That's really helpful. So again, another big thank you to you, Danny and Derek, for wrapping up our talks here. But don't go yet. Next up, we are going to hear from Dr. Abdullah Al-Raji, who's the Director of R&D Department at ST Dama. Dr. Al-Raji, are you there? Yes, we'll just wait for you to get off mute. It's always a bit of a moment. But we're really excited because, yes, there you are.
Yes. Good evening, everyone. Good morning for some people, and good afternoon for another also. So I will just give a quick talk about this lecture today in Arabic. So if I just will give you a second to translate, please. السلام عليكم ورحمة الله وبركاته. أنا معكم عبد الله الراجحي، مدير إدارة البحث والتطوير في استدامة المملكة العربية السعودية. حقيقة أرحب فيكم جميعا في ختام الورشة الافتراضية الثالثة، وأشكر الجميع على الحضور وعلى المشاركة. أنا شخصيا استفدت كثير جدا من المحاضرات اللي عرضت. إذا تسمحون لي بس استعرض على عجالة ما تم تقديمه خلال اليوم، بعد ذلك نتكلم عن يمكن أكثر المخرجات اللي سجلتها، وقد يكون بذلك بعد ذلك أيضا بعض التوجيهات الأخرى منكم. تعرفون جميع المملكة العربية السعودية تواجه تحديات عديدة جدا، من أهمها المياه. لذلك كل الجلسات الأربعة تحدثت وكانت النقطة الأساسية فيها عن محاولة الرفع من استخدام كفاءة المياه والري في القطاع الزراعي، وهذا شيء منتظر ومتوقع، لأنه فعلا التحدي الأكبر اللي تواجه المملكة العربية السعودية كان هو ولا يزال المياه وجودتها في القطاع الزراعي. النقطة الثانية كانت في الغالب عن الهارش انفايرمنت أو درجة الحرارة المرتفعة، الجفاف وغيره من المشاكل التي تواجه الزراعة. لذلك كان يمكن من الأهداف الأساسية الاستراتيجية لهذه الورشة 3 نقاط أساسية، اللي هي تحقيق الأمن الغذائي، زيادة الإنتاج المحلي من الأغذية الطازجة والآمنة بنفس المساحة ونفس التكاليف، الاستدامة المائية بتوفير استهلاك المياه بأقدر كمية ممكنة، كذلك الجدوى الاقتصادية اللي كانت خلق الفرص الاستثمارية مربحة ومستدامة. وأتوقع أنه التحدي يكمن في النقطة الثالثة اللي هي الجدوى الاقتصادية، وإثبات إمكانية منافسة أو قدرة الكنترول انفايرمنت سيستم أو حتى الفيرتيكال فارمينج على منافسة الزراعة التقليدية العادية. في الجلسة الأولى كان فيها عندنا الزراعة المحكومة اللي هي الكنترول انفايرمنت سيستم أجريكلتشر، تكلموا بشكل مسهب عن توفير المياه، ثم تقليل الاعتماد على المبيدات الكيميائية، وتحسين جودة المنتجات. في الجلسة الثانية كانت الجلسة عن الزراعة العمودية الفيرتيكال فارمينج، وتكلموا أيضا مرة أخرى زي ما قلنا على توفير المياه، تسريع الدورات بالنسبة للمربين، تربية النباتات وتربية المحاصيل الاستراتيجية وتطوير الوراثي. أيضا كان فيه القدرة على عمل 3 إلى 5 مواسم إنتاج سنوية لبعض المحاصيل الاستراتيجية اللي كان من ضمنها تجربة اللي كانت في الصين عن طريق الزملاء في شركة نكسس، اللي نحن إن شاء الله قريبا عندنا تعاون معهم في القريب العاجل إن شاء الله. الجلسة الثالثة كانت عن البنية التحتية والرقمية، اللي كانت عن الأتمتة والذكاء الاصطناعي، أتمتة العمليات الزراعية، ونفس الموضوع أيضا تكرر مرة أخرى زي ما ذكرنا، توفير المياه عن طريق الأتمتة والأون ديماند إريجيشن أو الري في عند الحاجة، أو الري عند الحاجة الفعلية للنبات. وكان أيضا فيه تحديث ونقاش عن التسميد، أو عفوا عن الاستخدام الأتمتة في رفع جودة المحاصيل بشكل ملحوظ. في الجلسة الرابعة كنا تكلمنا عن بناء نموذج اقتصادي مستدام، وكان في تحدث أيضا عن العائد الاستثماري وعن توفير المياه كذلك، وعن ما يمكن أن يكون ضرورة لدعم حكومي وحوافز بالذات للطاقة، توفير الطاقة بشكل ضروري في القطاع. إذا كان ممكن أطلع بالمخرجات الرئيسية، ممكن نقول المخرجات الرئيسية هي أن يكون فيها نقلة نوعية حقيقية نحو الزراعة الذكية في المملكة العربية السعودية، بحيث تكون في مخرجات متعددة، اللي أولها الكفاءة في الموارد، إمكانية توفير المياه يعني نقطة مهمة جدا، وهي العامل الأساسي حقيقة في تبني سواء الوزارة أو المملكة أو الباحثين في المملكة العربية السعودية، وفي المناطق الجغرافية اللي تشابهنا بالظروف المياه، بتقليل الاعتماد على الطاقة. أيضا كان من خلال تصميم مبتكرة وطاقة متجددة. عندنا الإنتاجية والأمن الغذائي، يعني قدرة على عمل 3 إلى 5 مواسم إنتاج سنوية للأمن الغذائي. نفس المساحة كان أمر جدا مهم وفعال. الجدوى الاقتصادية، يعني أعتقد أنه لازم يكون هناك في نماذج واعدة تظهر إمكانية تحقيق العائد الاستثماري فعلا خلال 5 إلى 7 إلى 8 سنوات، مما يجذب الاستثمارات النوعية ويستطيع فعلا إقناع المزارعين والمستثمرين في أنهم ينخرطون في هذه الأعمال. الاستدامة البيئية المهمة جدا، سواء عن طريق تقليل الانبعاثات الكربونية أو عن طريق الحد من استخدام المبيدات، عن طريق المكافحة البيولوجية والتقنيات النظيفة اللي ذكرها الدكتور ياوكا. أعتقد أن هناك مجموعة من الإجراءات التي نعتقد أنه مناسب على البدء فيها من حيث الرؤية إلى التنفيذ. أعتقد لتحويل هذه الرؤية إلى واقع ملموس نتطلب أن يكون في هناك تضافر من عدة جهات، سواء من الحكومات والمؤسسات الحكومية، إنه توفير حوافز بالذات للأبحاث المتخصصة بالطاقة وبالكنترول انفايرمنت اجريكلتشر، ولا اللي بالفيرتيكال فارمينج، دعم البرامج اللي في تطوير المهارات والقوى العاملة. عندنا أكيد في نقص في القوى العاملة والفنيين المتخصصين في إدارة الزراعة العمودية والزراعة وتحت الإضاءة الصناعية. تطوير سياسات داعمة للابتكار والبحث في المملكة العربية السعودية أيضا، ويمكن هذا أحد النقاط اللي تتولاها الآن وزارة الزراعة بشكل ملحوظ جيد. الباحثين الأكاديميين اللي أنا منهم، أتوقع أنه مهم جدا نبدأ في عملية تطوير الأصناف الوراثية بشكل أكبر لتتكيف مع احتياجاتنا فعلية في المملكة العربية السعودية، والربط أكثر مع المزارعين، أن بناء شبكات أكثر مع المزارعين. المحاولة في إقناع المزارع بأنه فعلا البحث هو ليس ترف، البحث هو حاجة ضرورية، وبالنهاية هو المستفيد إذا استطعنا إقناع المزارع بأنه النموذج اللي نقدمه للبحث أو للتجربة أو للدراسة البحثية هو عبارة عن نموذج ناجح، وسيوفر عليه طاقة، سيوفر عليه عمالة، سيوفر عليه أيضا مياه، فبالتأكيد أن المزارع سيتبنى مثل هذه المشاريع. المستثمرين القطاع الخاص أيضا لهم دور في التحول هذا، مطلوب منهم تبني أكثر التقنيات الزراعية الحديثة. المستثمرين والقطاع الخاص عندهم القدرة المالية أكثر من المزارعين الأقل حظوة في أو أقل إمكانيات، ويستطيعون أيضا عمل تطوير نماذج لمجمعات المزارع. أنا أعجبتني المحاضرة الأخيرة، كانت فعلا رائعة، ونتمنى فعلا يكون في هناك نوع من الدراسات المشتركة مع الزملاء في الفارم باركس. المزارعين أيضا عليهم النقطة النهائية اللي هم تبني التقنيات الحديثة. أنا أعتقد أنه لا نزال مقصرين كباحثين في طريقة إقناع المزارع البسيط، المزارع الصغير، المزارع المتوسط، في أن أبحاثنا فعلا تستطيع أن تساعد وتسهم في رفع دخله ورفع إنتاجيته وتحسينها. في الختام أنا أشكر الجميع حقيقة على وقتهم اللي أعطونا إياه. كان يوم طويل، البعض كان يوم مرهق، لكن أشكركم جميعا. أشكر هنري لأنه فعلا يعني أنا ما أدري هو نام ولا لا، يعني أعتقد أنه إلى الآن لم يحظى بقسط كافي من النوم، لكن نشكره على ذلك، ونتمنى إن شاء الله أن نتعاون وثيق في المستقبل. الشكر للجميع، وأترك الكلمة الأخيرة للأستاذ هنري، وشكر لكم جميعا. في أمان الله.
Thank you so much, Dr. Al-Raji, for that. And just to wrap things up here a little bit, it has been such a privilege to moderate this event and work directly with Estidama under the support of the Ministry of Environment, Water and Agriculture from Saudi Arabia. You know, there's few things as exciting as agriculture that we can respond to and solve and foster future generations. And Saudi Arabia represents a country with massive opportunities to do so. So it's really inspiring to hear all of these ideas that our colleague just went through and reviewed for us that we learned from. My team at Agritecture, we will also be doing some conclusions from this workshop and sharing that so that Estidama can publish it. So stay tuned for that, and you'll receive the recording of this as you've registered for the event. I want to give a real special thank you to our interpreter today. I'd also like to thank our technical team that made this possible behind the scenes, managing all these different speakers. I'd like to thank my colleague Nico Simos from Agritecture that's been helpful and assisting throughout this process. And of course, Mustafa Garay, who has been here at Estidama helping us throughout, and Dr. Khalid that's invited us to do this. So thank you to everyone involved, including yourselves as participants and our speakers. Let's continue to share, let's continue to collaborate and foster a more food secure future. Thank you so much.